Welcome to CSharpCorner, the social fi platform empowering creators.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep. Every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi everyone, and welcome to the day one of Software Architecture Conference. For those who have been watching C Sharp TV and is updated with CSharpCorner, you all may know that this is the fourth edition of this conference. We started this conference in the pandemic. We received a very good response from all of you, and Software Architecture Conference remains one of the most loved conference and by the audience. And in the community. So I'm really excited to welcome you all once again. We're joining once again after almost 1 year. I remember last year we did this conference around the same time. That was August 13, 14 or something. And this year we are back and we are even bigger. We have a 4 days of conference coming up starting from today. That is day one. It goes till Friday. Each day has about 8 to 10 sessions, all curated sessions. They're the best sessions that, you could get in a community conference. So, and I see a lot of engagements in the chats already. I see Vishal. Hi, Vishal. Thanks for joining. I know he's a CSharpCorner MVP. We also have Saurav Prajapati. Hi, Saurav. We have Murat joining us from LinkedIn. Sarthak, of course. Okay, he's a whale. Sarthak is also CSharpCorner MVP. And we have then Ashish Patnagar. Quite a few folks joining us from LinkedIn, Twitter, and from all around the world. Scott says, hello, Sophia, welcome to this conference. So we have about 3 minutes before we go to the main content of this conference. But before that, there's a few things I really want to share is about. First is definitely the code of conduct, right? We want you all to be very nice. That's all it means, right? Be nice to the folks in the chats and on the social media where about this conversation is going on. You're free to go ahead and ask any questions to the speaker. We're going to take all the questions towards the end of every session. So please feel free to go ahead and drop your questions in the chat, and let's make sure this conference is well accepted by everybody. We have a packed day one. The first session that we are starting today is actually by Tiago, followed by we'll have a session by Anmol. It's going to be about from fragile to fearless. Then we'll be joined by Faris, who's going to talk about caching, payloads, and other dark arts in the more on the front end side. Then we'll have Sakshi joining us talking about the architect resilience. Alexander will talk about refactoring, and then Mahesh will join us talking about the AI architecture. Then it will be followed by Indranila, who's going to talk about, the deadlines and technical depths we all go through whenever we are delivering the solution. Then finally, Sri Varma is going to conclude with building secure APIs and its architecture. With that said, ladies and gentlemen, I am going to hit this conference live and invite the very first speaker of this conference, Tiago, while he's waiting for us behind the scenes. We all love Tiago. He is very popular in the developers community. I have known Tiago for almost like 4 5 years. I always enjoy hosting him. Tiago is an Azure Cloud and AI architect and advisor. He's a trainer, public speaker, author, Microsoft MVP, all the great things that you can think of. Tiago, hi and welcome to the Software Architecture Conference.
Hey, welcome. Yeah, it's a pleasure to be here, Simon, and thanks once again for for accepting my sessions and to be able to be here and bother some developers, some software architects here for 35 minutes about how to build resilient cloud architectural solutions. It's going to be, I think, at least a very interesting session.
Exactly. We are looking forward, Tiago. Please feel free to go ahead and share your screen. And
Yep,
then
sure.
everybody's watching, please feel free to drop your questions in the comments. We're going to take it towards the end. And later on, we can also talk about the evergreen get certified cushion that Tiago always have in the background, right?
Yeah, those pillows are always very popular and always a big conversation topic, by the way. Okay, and if people were in Microsoft Ignite the last time that that was in Orlando, if I'm not mistaken, I think it was Orlando. Yes, they are from there. Okay.
All right, Tiago, off you go.
Okay, so thank you so much and welcome everyone. Yeah, we have 35 minutes. Okay, so let's try to make use of our time. My name is Tiago, and just doing like a very short kind of presentation about myself. You can go on follow.tiagocosta.com and get in touch with me, and if you need some more help after this session, just go there, send me a message on LinkedIn or your social network of your preference. It's always open for everyone to reach out. What I do for a living, well, I'm a cloud and AI architect and advisor, which is kind of a fancy way for me to say that I help companies moving into the cloud by designing solutions for them. Sometimes it's when we have already a solution that's already on-prem and we want to push it into the cloud. Sometimes there are cloud native solutions, which, let's be honest, that's when we are a little bit more excited for that. You can also find me in the classrooms, so sometimes virtually or in person. I also teach, so that's kind of a big passion of mine. I don't do it as often as I used to back in the days, but I still do it, and it's something that I will never not doing. So yeah, you can still find me, and I always like to share my experiences and all that. I create a bunch of content, and I'm also a public speaker, so you can also find me, in conferences like this, or Microsoft Ignite. That's going to be in November in San Francisco this year, and things like that. Okay. I'm also an Azure MVP. I have a bunch of certifications, and I'm from what we like to say the sunny Lisbon, Portugal. Okay, and it's actually very, very, very hot. Nowadays, even for our standards. Okay, so it's we are like passing through that right now. Okay, so but yeah, what are we going to talk about? So we're going to talk a little bit about why resilience matters, talking about the resilience framework. What is all this thing here, And then some Azure services, that are key for resilience. And I'm trying to open up this, this conference in this session. Look, I'm going to show you some Azure services, but very quickly, you can find also services in other cloud providers or even in on-prem. Okay, so pretty much the concepts are pretty generic. Okay, then common failure scenarios, design patterns for resilience, and some key takeaways. Okay, so first of all, let's talk about why resilience matters. And when we talk about specifically in cloud, okay, so cloud resilience is what we like to say the ability of a system, an application, or a service, okay, to recover quickly and continue to operating effective, even at the face of disruptions, okay? So this is not about avoiding failures, okay? But it's to minimize the impact of such failures. Because let's be honest, look, failures will always happen. So that will be something that, yeah, you can't say they're not going to happen, okay? Maybe one day we get there, but not today. But here is the ability to recover quickly, okay? When something that we're not expecting will happen. So we have fault tolerance, that is systems to be able to continuing to function even when one of the components fail. We have redundancy concepts too, when we can have multiple instances, or we can have like backups to avoid that single point of failure. And we can also have disaster recovery solutions, which is rapid restoration of the services when we face like a major outage. So we can start to, by the way, like very quickly start to kind of divide, okay, all this within those three concepts that we have. Why this matters, okay? Because look, first of all, like I was saying, downtime is inevitable, okay? We can have stuff like we see over there, hardware crashes, okay? There's a cyber attack, there's human errors. So all of those are, things that can happen and may cause, downtime. Also, customer expectations. What is the customer expectation? It's, always on. It doesn't matter if you pay the service or not, customers will always want that. That will be always the expectation for everyone. We also have business continuity. Okay, so like we say here, operations, they should persist even when we have those disruptions. Okay, because we need to make sure that our systems, are redundant. They are resilient to small issues that happen here and there in some of the modules that we have in our architecture. Now, let's talk about a real world example that we had downtime. So there's a case which is basically a system that Microsoft has, or I don't think actually this is Microsoft, it's a third-party company, to do tenant provisioning. And, in May 2025, there's actually a downtime on this that caused lab hosters and things like this to have major impacts in their Microsoft 365 training environments. Okay, this even led to some courses that didn't have a lab environment for students, okay, to do some exercises. Okay, unfortunately, I personally was not affected by this, okay, but I know a lot of companies and a lot of other trainers and a lot of other people that were affected to this, and they didn't have let's just say the best experience, okay, when it came to this kind of like training and things like this. Look, impacts on this: risks of cancellations. You need to have emergency communication and mitigation strategies for this, how you can handle this. And I can tell you that most organizations out there, they didn't have any. Okay, they were like, oh, this happens, what about now? And they were trying to figure it out, things on the fly. You can't do this. You have to have processes in place that when this happens, what is okay, the communication plan. People never plan for this kind of stuff, okay? But you need to, okay? Because that's also important. And that's the key part of this slide, that I just wanted to tell you. There's also, this is basically not me saying, it's a study that talks about the cost of downtime. Look, it doesn't matter the value here. I even forgot to put a reference for the, for the from where this comes from. But it basically, I think you can agree with me that if you have a system that is stopped, okay, in a mid-sized company, a small medium business, it can cost you stuff like up to 10K, okay, in USD, so US dollars, okay. If it's an enterprise, it could be millions because a system is not up. Imagine an airliner, okay, like it happened a few weeks ago, where they had an issue. I don't know if you saw Alaska Airlines in the US. They had an issue, okay, with their system, and for a few hours they couldn't board people. People couldn't check in their flights. They had to land most of their fleet. Imagine how much this was. Okay, it's millions and millions and millions because you have hundreds and thousands of passengers that couldn't board. They lost connections. You had to give them, meal vouchers, maybe even put the people in an hotel because they only had a flight, in the next day or so. Correct? Imagine all this. We're talking about millions. Okay. There's also an example here in 2021. Amazon had 1 hour outage. Okay. This cost them, according to them, okay, around 100 millions in lost sales. Okay. You might say, oh, then people will buy it later then. Well, we can have that discussion. Okay. But it is not the time and the place today. But sometimes what happens when your store is not working and you actually need to buy something, you go and you search some other stores. And maybe you are happy with that other store where you bought stuff. And now you're like, oh, yeah, this is also nice. I never even came here because the other one was always working. So sometimes this is a loss of sale that can be lost for years and years and years. Okay, because you just found another place where you can buy things. Okay, so that's also important. So then resilience. I just want to say, look, this is not an option. Okay, it should be your core principle, and this should be something that when you start this, you should think about this. This is by design. You need to think about. I'm building things, and I need to build things thinking about resilience. So for this, we talk about the resilience. Okay, the resilience framework, and actually, there's actually a great resource. Let me see if I can find this here. There you go. Let me just open here. Okay. And I can just put it here. So this is a great resource, okay, that you can find this, and I can try to, to send a message in here. Maybe I can put here, and Simon can try to push it. But basically, this website here, talks about reliability design principles, okay? And there are tons and tons of resources, okay, like checklists that you have, okay, with their codes that you have there, like hey, add redundancy at different levels, okay. Look, this is like a candy store when it comes to resilience when you're designing an Azure architecture, okay. And there's lots of recommendations here, okay. It's basically recommendation about simplicity, about critical workflows, flows, and things like that. So there's like lots of stuff here that's actually like awesome. I don't create an architecture, okay, without going there and reviewing some of the stuff, even if I know that by heart by now. But I still always go there. Yeah, sometimes I might have missed something, okay? Who knows, right? So I always try to do that. So also important is talk about reliability design principles. And this is where we talk about business requirements, okay? So with this, we talk about, hey, gather clear requirements, okay? About user experience, data, workflows. Quantify, okay, successful measures for the components and the system flows that you have. Like what is the require for this to be up? Is it 100%? Is it 99.9? Is it 95? Who knows, right? You need to know that, and also understand platform limits, dependencies, and also the impact that they're going to have in resilience. Number two will be design for resilience. Okay, so you should identify those critical components, the potential failure points, so that you can even prevent what we call cascading failures, which is something that fail here and then fail. In all the flow, things start to fail because there's that dependency that we had before. Okay, then there's number three, which is designing for recovery. Look, guys, like we said, failure is going to happen, so you need to design your solution thinking about, hey, how I can recover this solution. Sometimes we might have an amazing design, but then the recovery might not be as great. Maybe we should redesign that so that we also think about, if something happens, can I recover this easily or not? Okay. And then, of course, we also have to basically to design for operations. Okay. And so when we're talking about design for operations, we talk about build observable systems with telemetry. Okay, we need to simulate failures. Okay, we need to automate processes to minimize human errors. So all of this. And there's a number 5 too. There's a fifth option here. Okay, and what is that fifth option that we have here? Keep it simple. And this is so important for me that I even basically created just a slide for this. Okay, so why keep it simple? Okay, because you need to remove basically unnecessary complexity, from the architecture, from code, from operations. That's basically something that we should do on all of this, and also use the platform provided features that you have, in order to minimize development time. That's also something, and also ensuring all the time this efficiency. Okay, so with all this great stuff that we talked about, let's actually go in Azure and let's start to think about some cool services that we can actually use to make things more resilient. Okay, and number one, VMSSs. Okay, and yeah, I on purpose I didn't put there what it is, but it's virtual machine scale sets. Okay, I'm sure some of you already knew that, some not. So, for everyone to be on the same page, there you go. Then we also need to think about high availability, load balancing, and even storage redundancy. And this is kind of like, the basics of all of this. Okay. So talking about virtual machine scale sets, look, this is an awesome service, especially if you're going to work a lot in infrastructure as a service, which, let's be honest, when we are talking about the enterprise world, if you talk with me, I'm more of a PaaS person than an infra person. Okay, I think there's a lot of platform as a service stuff that is like awesome, and customers, they should go that route. Nevertheless, the reality, and the comfort that some customers have in running infrastructure as a service, it's a reality. Okay, so we need to think about that, which means lots more work for me. Okay, which I think it's not needed. I think we'll be much better off if we could do this directly with PaaS services. So, but yeah, look, more hours of consulting for me. I'm not complaining about that. Okay, but as you can imagine, I think customers will better off with PaaS sometimes, but this is still a basis of a lot of customers out there. Okay, what do we get with this? Automatic scaling. You also get high availability with this. You get load balancing integration, and you can even get a uniform or flexible orchestration mode on this. So, for example, let me just tell you this. The other day, I was actually designing something for a customer. We're migrating something that exists on-prem, and it's a three-tier application. Okay, he has a bunch of web servers, a bunch of application servers, and some database servers. Okay, nothing fancy, like the traditional three-tier design from back in the days. Okay. And the customer doesn't want to change that because they don't want to, write more code, update that. So we actually needed to migrate that as much as we could as is. Okay. So I was like, okay. So my customer's like, oh yeah, we have 10 VMs here for, let's just say, the web stuff. So the front end, oh, there's like 10 servers. Let's just create 10 servers. Let's put a load balancer on the top and we're happy with it. I was like, well, no. Okay, no. At least let me create you a VMSS, because of course you can get this automatic scaling. If you have more load, we're going to be able to give you, more capacity. And also when you have less load, you can actually have less capacity, saving, of course, money with all that. Okay. So that's just one of the things that, we can do on this. So some use cases for this, that we have. Web applications was my first one, and actually that was something that I actually did a few weeks ago. But it could also be batch processing when you have to, basically do, some big chunks of processing, and you actually need to have a large capacity. You can instantiate, 10 instances on a VMSS of a really large VM, and you have those 10, instances working in a parallel in here. Okay. Then we also have for dev test environments. Yeah, sure, you can also do that. And you have a bunch of other services, like AKS, for example. Oops, where is AKS? There we go. Like AKS, like Azure Batch, also, for example, that actually behind the scenes, when you create a pool, you're actually creating a virtual machine skill set. So it's actually very, 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 very important, okay, for us to understand virtual machine skill sets, because then you also have other PaaS services that actually they depend on this. So the limitations that sometimes you find on this is the limitations that are transposed, for those PaaS services, like, for example, AKS, app services, and, and Azure Batch, etc. So on. Okay. Number two will be about what? Number two will be about high availability. And look, high availability, we have several options for this. Okay. First of all, we have availability zones. I love availability zones. I'm a huge fan of this, and we're going to talk about them in just a minute. But you also have availability sets. You can just do like basic load balancing, or you can even just talk about storage and, building, your storage solution like Azure Storage Accounts, okay, in a way that, it will be resilient. Okay, so that will be, something that we can do with this. Okay, so talking about availability zones and what they are. So when your region supports availability zones, that means that you're going to have at least, 3 zones, in that region. 3 zones means, or 1 zone means 1 or more data centers. Okay, and you always have 3 zones. Okay, so at least you're going to have 3 data centers. Okay, but the data center concept here doesn't matter at all. The thing is, when you're creating, for example, a virtual machine, you can explicitly say in which availability zone you want to deploy your virtual machine. And if you want to have something that is resilient, you're going to spread your virtual machines across availability zones. So talking about VMSS is you're going to say, I want this virtual machine scale set to be created, and I want to use, let's just say, all the zones available. So if you have 3 instances, each VM instance will be in a specific availability zone. And why they are great? Because each availability zone has independent power, independent cooling, and independent networking. Okay, so all of those things, they are independent from each other. So if there's an issue with power that affects, let's imagine here, okay, availability zone 2, that means this is not working. Well, that's not a big problem because you still have parts of your workload deployed in availability 1 or zone 1 and zone 3 in this case. So your stuff still works. Got it? Okay, you don't have all the compute capacity available. Sure, there's something that's going to be affected. Okay, that's definitely something that will happen. But in this case here, okay, yeah, that's not a big problem, okay, because you still have, okay, the possibility of your service is not done. Okay, it is still working. So this is, for example, some of the key features that you can have with this, which is redundancy, high availability, and also very, very low latency, because we're talking about sub millisecond. So sub 10 milliseconds of latency between zones. Okay, so this is actually really, really, really fast. Okay, and there's almost no latency, even if you're talking about having multiple data centers and stuff like this. Okay, so that'll be something that we can have. Also, you can also have we have like load balancers that they can also be spread across multiple zones, so that you're not going to have, like I already saw, customers having virtual machines spread across availability zones, but then they add the concept of a zonal load balancer, so that load balancer is in a specific zone. If that zone gets down, all your solution is down. So probably that's not a great idea. So we actually had to change that. Yeah, the customer tried their best. Okay, I think they're watching and everything today. so I know that they tried their best, but they were still not there yet in terms of knowledge. But now they are, and they're actually pretty good. And I'm not saying that's because they are watching. Okay, they're actually pretty good. They learn very quickly. And when you show the concepts, they were like, oh yeah, of course we can't do that. Yeah, so we need to design this in a different way. Okay, so some design ways is like this. We can have a region, we can have a different region, and we can have basically also availability zones on that region too. But sometimes we might have a region, okay, that does not support availability zones. Okay, and we need to make sure of that. Almost every region now supports availability zone, but we still have a few that they do not. Okay, they do not support this. Okay, so very quick demo. Okay, which is how we can basically very, very quickly create services that they're going to support this. I'm just going to use the portal. I'm sure everyone understands that you should basically do things using templates or something like that. The portal is not collaborating with me. Okay, let's try again. This is not good for my demo. Okay, let's do this again. Oh, now it works. Well, whatever. Okay, so if I just search for virtual machine scale sets, okay, so what can we have in here? If we try to create one of those, just because one of the cool things that we have here is that we can say, well, this doesn't matter where I'm going to put this. That also doesn't matter the name. What I want is this bit in here. Okay, So see here, what we have here is that we can select, okay, which zones, okay, we want our virtual machine scale set to be spread, okay? So we can say zone 1, zone 2, zone 3, or just zone 1 and zone 3, or all of them, okay? So it's totally up to you to do that, okay? If you create, for example, a virtual machine, so let's go to virtual machines. Let's create here, a virtual machine, and again, really doesn't matter. Let's just say VM1. There's availability options, okay? And under availability options, so we have no infrastructure redundancy required. Look, sometimes I'm just doing, a VM just to have some fun, okay? So that will be something that I can just say no infrastructure requirement. I'm just going to have some fun with the VM, just making some experiments and things like that. I don't need any of this, okay? If I'm running something in production, maybe availability zones will be a great thing, okay? So maybe I want this, okay? And I can actually select, okay, which zone, okay, I want this to be deployed on, okay? And you can just come in here and you can just say, oh, look, this VM that I'm creating, I just want this in zone 1, or look, I want this in specifically in zone 2. So if that's something, yeah, sure, you can do that. Just be careful of something. Zone 1 means something physically in that region for your subscription. If you go to a different subscription, so I changed this from one subscription to another, zone 1 and zone 1, they might not be the same thing. Got it? So that happens because that needs to happen because everyone was always selecting zone 1. So physically, zone 1, it's dependent on the subscription to mean something. So that means that zone 1, it's not. Imagine that we only had 3 data centers, DC1, DC2, DC3. Okay, let's imagine that very basic example. Everyone was selecting zone 1. So zone 1 was going to have lots of VMs, lots of compute being used, and then zone 2 and zone 3 less. Okay, so what happens is, we don't have, all of that. So that it's dependent on the subscription. So what zone 1 is for me might be for you zone 2. And for other customers, might be even zone 3. Got it? So that depends on the subscription ID to be calculated. Okay. So that's this bit here. But we also have, of course, some use cases for this, like mission critical applications, to have something that covers disaster recovery, also for data protection scenarios, things like this. If you're running this in a in a region that does not support availability zones, you also have availability sets, okay? And availability sets, you're going to logically group your workloads. So for example, remember that 3-tier workload that I was talking about? Web, some kind of application code, and then the database. Each one of those, it's going to be in a specific availability set. And this is going to control how your virtual machines are going to be placed in the hardware within the Azure data center. So we have fault domains, and we also have update domains. Okay, so this VM here is going to be placed here, okay, in the fault domain 0, update domain, in this case 1, but actually those also start in 0, okay? And then, we have another VM. It's going to be placed in a different rack, also in a different update domain, okay? So, what we have with this, well, for high availability purposes, because what's going to happen with this is that basically, we want our virtual machines to be spread through different racks, because imagine this rack goes offline. Doesn't matter why. You still have the VMs that you have on the other racks here available for you. Eventually, this one here, oh, it's now operational. Oh, now you have everything back again. Good stuff for you. Okay. Also, those update domains, it's because when Microsoft is actually doing some maintenance on the host machines, what happens is they are never going to do maintenance in different update domains at the same time. So if they're doing maintenance in update domain 1, this VM, and also this VM, because it's also in the same update domain, see over there, they are not going to be working, but all the other ones, they're going to be okay. Eventually, that maintenance will end. So those two machines are going to be operational again. And hey, happy days. Now you have all the stuff, back again for you. Okay. There's no extra cost, okay, on this, nothing. And I just have like a very quick demo for this one here too, which is what you're creating that virtual machine where I was, there's the availability set here, and now you can create your own availability set where you just need to give it a name and how many full domains you want and how many update domains you want for this. Okay, so it's up to you to define this, and now things will be spread within that region that way. Okay, so that's actually something pretty pretty cool what you can do with this. Talking just about storage account redundancy, which is like the last slide that we have. Look, we have local, zone, geo zone redundant storage, and this will basically spread your storage replicas across different regions too. So that's also something that you need to look at in terms of a storage perspective, so that you also talk a little bit about the storage story in all of this. And because we're just out of time, key takeaways, design always for failure, because failure will happen. Try to use as much as you can from the platform native tools that you're going to have. Regular test your failover. It's not believing, oh yeah, this will work. No, actually test, turn things off, see what happens, make use of availability zones and use a resilience proven design pattern, and you can find them in the Azure Architect Center. So this is it from me. I hope that you enjoyed. I don't know if anyone has any questions, but my name is Tiago, and this is how you can build resilient cloud architectures. So, and if you want to stay in touch, follow.tiagocosta.com, and it will be my pleasure to have you there and to have some interactions with you.
Wow, Thiago, loved it. I really like, you went on, you really opened your Azure portal. Sometimes it's just that basic thing doesn't work, right?
Yeah. I think I already had it open, and something my credentials expired or something like that. The token, but yeah, you can always close it again, try again. And I actually have a second demo environment just in case my first demo environment doesn't work. I already built a second one just in case. So we were okay. I was not worried about that, but it already happened to me in a conference doing a session when actually Azure was down. And I was not understanding why things were not working in my demo. And then someone from the audience says, "Hey, Tiago, sorry to interrupt, but I think Azure is down." I was like, what? That was not fun at all. But it is what it is, right?
Yeah, you get stressed up on the stage. You feel like, why it's not working? You're staring down at your screen, right? Everybody's waiting. Okay, something's going to happen.
Yeah, well, it is what it is, right?
Exactly. Okay. Let's take a few questions from the audience side. Sophia is asking, how do these Azure native resilience patterns translate to a hybrid cloud environment with on-premises components?
Yeah, so great question. Yeah, it's going to be majorly different, of course, because
Hmm.
in on-prem you actually need to do your own stuff, and you need to think about the hardware resilience bits and all that. Yourself having things like having spare hardware, spare hard drives, and things
Hmm.
like that. So I'm actually now moving to a new office, and by the way, I think I just got the package because I heard you know a lot of noise out there. And one of the things is, even for example, having spare hard drives. What happens if one of the hard drives gets broken? Yeah, you have resilience with redundancy, but we need to have spare stuff. Connecting with this, you can also think about Azure Arc. Azure Arc can actually help you a lot on this story. Maybe
Yeah.
even thinking about Azure Local, and actually also, with Azure Local, thinking about this, and you can actually do certain things like this. Okay, so that'll be something that we can actually do. Okay.
Yeah, perfect. So, okay, thanks for answering that question, Tiago. Thanks for Sophia for asking it. Let's take one more question
Yeah, sure.
from Scott. He's asking, how does the infrastructure as code play a role in building and maintaining resilient system?
Yeah,
Thanks for
no,
this session,
great,
Tiago.
great question. I actually have this because I actually have a workshop of a full day on resilience, and I actually talk about exactly about this. Okay, um, so look, using a DevOps approach, being Git through GitHub or through Azure DevOps, it really doesn't matter for today. For the session, that for the resilience bit, should you choose something? Okay, you can even be one that's not those. Okay, and everything like in Bicep templates, like
Yeah,
in Terraform templates. Okay, because if you actually need to rebuild everything from scratch again, and that in the end could be um you know some mode of doing it. Yeah, you need to have some kind of templating, or even PowerShell scripts or
yeah,
Bash scripts, if that's what you're into. I'll go more for the templates. Okay, and then sometimes, yeah, then you also need to configure some stuff, so it will be a mix of templates plus some scripts, because scripts are more imperative. You
mm,
actually need to explain exactly all the steps, how you get to that end state that you want. When templates will be more declarative, where it's just, this is my end state that I want. How do I get there? It's not up to you. You just declare that. Then it's the platform that needs to make that stuff. Okay. And if you have all that already defined, that'll be great. Okay. Because then you're going to be able to rebuild, something like from scratch using that. And that's, for me, is something that in all my designs, I always have a concept of infrastructure as code, and also for DevOps, because then there's also application code, right? It's not
mhm,
just building the infrastructure. Oh, now you need to put the code there, right? And also not just the infrastructure as code, but now also the code, how you're going to put the code there, how you're going to run this, right? Maybe there's still data that needs to be migrated, so it's actually very complex and depends on app per app, because I can give you an example and then someone can always get, oh, what about if we also have this and this and this, right? I was like, yeah, that's really hard. That's why
yeah.
we do consulting, right? For specific cases. And I really don't like to give that consultant answer, which is the it depends. Okay, but yeah, it's actually very true, correct? Yeah.
Yeah, that's true. That's true. I have a personal question, Thiago.
Sure, go
I
ahead.
love Terraform, right? I've also used biceps and arm templates. What I've lately realized is that, I really don't go and make changes to my infrastructure every single day,
Hmm.
right? I make it once, then I use it, right?
Yeah.
So, how often do you really end up using these infrastructure as a code? I mean, if I in the beginning phase, or maybe just to keep a record of it, it is good. but how often you really use it? Because
Yeah.
I don't see myself using it a lot.
No. Good. Very good question. So I can tell you, like, just one of my customers, where if you're using the app today, this runs in Azure. Okay, this is an app that runs on Azure. If you run the app today, you're using one infrastructure. If you're going to run the app, so today it's Tuesday, right? So if you're going to use the app maybe on Thursday for you, okay? Because Wednesday night, this runs in Europe, okay? Wednesday night, every week we deploy a new infrastructure.
Ooh.
Okay? Oh, yeah. And then there's some code that gets there. Okay, it's a SaaS application. Every week we have a new infrastructure. So those templates are, fairly
Helpful.
used.
Yeah.
And what about changing them? You probably were also asking that. We also change them from time to time. Okay.
Wow.
Because for example, it's not every week, to be totally honest on that. Okay. But for example, we introduce a new feature. Okay. That required some more modules to be created. So for example, we're not using AKS Kubernetes, and we build a module where we saw, well, maybe this will be better off in-app services. So we built it in app services. Then we got to a point that it was slow, we're not happy with it. We need to go to AKS, and we actually change that module, okay, into AKS, so Kubernetes services, and it's run on a Kubernetes services. And right now we're actually going to change it into ACA, so container apps, because we're not happy with AKS too. Okay, because we don't need AKS, to be totally honest. Is an exaggeration. And the team, it's not very good that is maintaining that. It's not very good in Kubernetes concepts. So I want to try to simplify that for them. So I think we're going for ACA. We're actually trying this right now. Okay, and there's also sometimes a second infrastructure that we create. We already have ACA running, and if you are one of our how do we call it, Canary users, okay, you're actually already using the ACA infrastructure. Okay, so we actually are running sometimes infrastructures in parallel, and we use concepts like canary releases or dark launching releases. Dark launching releases is you don't know you're trying be a canary is like when you're using Windows, like those dev versions of Windows, and being dark launching is you're using those, but you don't know you're using those. Okay, it's like we're playing with you, and you don't know that you're using like a very new infrastructure that is like that might not be 100% capable. So yeah, and then we get telemetry of that, how things are getting there. We do like something that's called A/B testing. So we compare performances of the two infrastructures, and we see Tiago is using, the normal infrastructure. This stuff is running in 3 seconds. Simon is using the new infrastructure, old shiny new infrastructure, and that stuff is running in 3.4 seconds. That's not good. That's bad. So we need to go back to the drawing board and need to change it back, etc. But if Simon is using that, and now it takes 1.5 seconds, let's imagine, let's be positive here, okay? Then we're like, okay, that might be good. And we test until one point, until we basically forward all the traffic into that new part. Yeah.
Wow. I've never really heard someone, I know people have used those tools like open telemetry and all that. But, not really many people end up doing A/B testing, right? So that's not very popular.
Yeah.
So I think you are really good architecture, and a practice of Azure cloud journaling in doing all this.
And look, and fair point for almost everyone out there. If you're not doing this, don't feel, oh my God, I should be using this. Look, sometimes you don't have the budget, and sometimes you don't even have the dimension that you actually need to do that. Let's be honest, okay? Most of my customers where we have stuff, and some of them are pretty big, we don't have the need to go that deep into this. So sometimes you see people doing sessions on conferences. All this amazing shiny things, but then you have to put that in perspective. Do I actually need this? Okay, because look, I always like to use the new shiny stuff and all the cool stuff, but there's also that. Let's put our feet into reality, see the budget that we have, the size that we have, the demand that we have, and what we actually need to use. Most of my customers, yeah, we have even large deployments where we're not going into this level. Okay, then I have others, fortunately, because I actually love to do that, where we can actually have, because we actually have the need, okay, to try this kind of stuff. Yeah, this is a SaaS application, okay, that has more than 100,000 active users. That means
Wow.
at least they log in once a month. Okay.
Wow.
Yeah.
Well, thanks, Tiago. I know I've taken more time from you than I blocked your
No,
calendar, right?
no worries,
Right.
no worries.
I really enjoyed your session, to be honest. I really love hosting you always. Is there any final thing you want to plug in before we move to the next session?
Yeah, just check out that website that I send, okay, and basically, yeah, exactly that one. He has tons of stuff for you guys, okay, to be honest. Check it out. You're going to find it super useful, all the information that you have there. And if you have any questions, even after this, look, send me a message. You can find me on follow.tiagocosta.com. Yeah, there you go. And find me there and send me a message. I'll be more than delighted, okay, to answer to any questions that you have after this. Okay, so there you go.
Perfect, Tiago. Thank you so much. Please take care of yourself. Enjoy all the upcoming conferences that you have. Traveling to places. I see you're very busy, and yeah, let's stay in touch.
Okay.
And I'll see you in some other conference. Thank you so much once again.
Yeah. See you. Bye-bye.
Bye-bye. All right, ladies and gentlemen, that was Tiago for you. Kicking off this 4-day software architecture virtual conference. No one better than Tiago could have done it. We now move to our next session, but unfortunately, our next speaker cannot really join us. It was a very last moment, so let's take a minute break, and I'm gonna figure out what I'm gonna do for next 25 to 30.
That ad, walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine, I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot, I deserve free reward.
Hi everyone and welcome back. This is day one of Software Architecture Conference and I'm your host Simon. I'm going to be with you for next 4 days and we now move to our next session. I'm going to make a few changes in our next session, right? The next session that we're going to bring to you is by Rustam, right? As I told you just now, we cannot present you the next session that was scheduled by Anmol, but we have another session that's by Rustam, and he's going to talk about scaling multiple podcasts and how you can do it with OpenAI API and everything else. So please mind it that this is a recorded session. We may not be able to take it. Actually, we won't be able to take it Q&A after this. But please sit back, relax, and enjoy this session by Rustam.
My name is Rustam, and today we are going to talk about my little project, scaling multilingual podcasts, automating end-to-end content localization with the OpenAI API suite, how to automate podcast translations with Whisper, GPT-4o, and TTS-1. In short, this is a talk about how to get a podcast in some random language and translate it to your favorite language so that you can understand everything, and that's it. Now let's move on. The first question you would ask, why do we need this thing? And there are multiple reasons. First one is for content creators, so that when someone creates a new podcast, they record it in some language, but they want it to be understandable by people from different regions, from different countries, for people who know and who don't know English. For example, if the original language was English, and so on. So if they could take their podcast and translate it automatically to some other language, then they would just increase their audience without much effort, without re-recording their podcast again. The second reason is that why we need to automate it, and it is because we want to record the original podcast as good as we can, with with all the tones and styles, with all the jokes, with everything, and we don't want it to be lost in re-recordings. When well, if you speak two languages, for example, if you speak English and some other language, you can make, and English is your main language, native language, and you can make jokes in English, you can add accent to your words, to your speech in English, but you cannot do the same for the second language. But if you use some software, it will do this for you, and this is a very good reason to use some automation instead of manual re-recording your podcasts. And the third reason is, of course, to work less, to reduce manual effort, because the less you work, the more time you have to do some other things, and you can spend it on recording new podcasts, or on your life, on your work, on anything. So it just saves time. So this on this slide you can see some of our core features which we have. I will go from the first one to the last one in sequence. So the first one is Podcast Downloader. This is a sub-module which we use to download original podcasts. So we have a platform which downloads podcasts from somewhere, and this is a module which does it. The second module is transcription module. Transcription stage is when we take the podcast and make it, I would say, take a transcription from it, and so after that we have just a text without any audio recordings, and then we will work with this text mainly. Text processing, we need to process the text because audio recognition tools may not recognize something, and also when you just speak in a podcast, you can have not finished sentences, and you don't want them to be present in the translated podcasts. So if you can make your podcast even better, why not, right? The next step is speech synthesis. So we take this improved text of your podcast and synthesize speech. We can use multiple voices for it, different voices. We can play with the speed of the podcast. We can do anything with it. It's just take your text and make it to a speech. The next one is auto assembly. This is, I would say, a bit of an artificial problem, and it arises because models which can generate text, audio from text cannot take a lot of text and generate audio from it. We should do this chunk by chunk. And for example, if we have a very long podcast and we have 3 different chunks, like first part, second part, and last part, then we have to merge them somehow. And it's not as easy as you might think. It's not like you can take byte array of the first file, audio file, second file, third file, merge them and be happy with it. No, because there are some problems, mainly with the metadata that you have in these files. For example, like length of the file of the recording, or different kinds of codecs that you use for producing these files. So you can have multiple problems and you have to solve them somehow. We did solve them, and I will tell about it later. And the last step is RSS generation. So the RSS feed is a thing which we can send to the platforms with podcasts, so that on these platforms, how does it work? They fetch these RSS feeds from somewhere. For example, if we host this RSS feed on some website or on some host, doesn't matter. These platforms check these RSS files from time to time, and when they see that there is a new entry, and the new entry is a new podcast episode, they add it to their platform, send notifications to users about this new podcast, and do other stuff. So this is only used by these platforms. Okay, let's go next. The key technologies that I used for this project. Well, I say we because we made it with a friend, but he's not here right now. But yes, I did it with a friend. The first and most important one, the programming language, and we used Kotlin for it. And there are multiple reasons for that. First reason is that it's pretty easy to write stuff on Kotlin. It's a mixture of Java and Python, and you have best of both worlds. You have the speed and type safety of Java and all the libraries that you can use in Java, you can also use in Kotlin. But you also have much better syntax than Java's in Kotlin. It's more like Python-y style, but with all the type checks, with the reflection, with everything. The next tool we use is Podcast4j, and it's just a library which we use to fetch podcasts from a library of podcasts. And for the library, we use podcastindex.org. This is a very huge library of podcasts, and it has pretty good API so that we can fetch info from there, and not only the podcast audio file, but also the name of the podcast, description, some images, some links, the list of authors, everything. The next one is OpenAI API. This is the heart of this project, and we use it for 3 purposes. First one is to transcribe audio, so that when we have the audio for the podcast, we can take just a text from it, just a speech. Then we can translate it to a language of our choice, and we use OpenAI to translate because it translates stuff like jokes, and it doesn't keep half sentences in it. So you can just translate it. You can just open ChatGPT and send a text to it and say translate to my language, and it will translate it with a very good quality. And the third model which we use from OpenAI API is to convert text to speech, so that when we have this text, we can create the speech, which is the final product of this service. Final product as an MP3 file with the podcast on the different language. So we also use HTTP with Gator like OGHTTP engine for Cater to do HTTP requests to OpenAI API. And that's just it. Cater is a very nice framework written on Kotlin for Kotlin, which supports coroutines and all this stuff. And it has very nice syntax for Kotlin. So it's really easy and comfortable to use it. Then we use Jackson for JSON data, and we have a lot of JSON data actually. The first stage when we have JSON data is when we download stuff from podcastindex.org. It all comes to us in JSON, and we have to parse it, handle it, save it somewhere, and so on. So in these JSON files, we can have like title of the podcasts, description, authors. We can have links to the images for this podcast. We have links. We also have links, a link to the MP3 file itself. We don't download it directly from the API. We just have this link, and then we hit another endpoint with this link and then download the MP3 file. The next one is XML APIs, and it's just to build an RSS feed. RSS feed is an XML file actually with structure like you have the root of the XML file, then you have an element which corresponds to a specific podcast, and then inside of it you have like title, description, and so on, and then you have a list of episodes with similar fields like description of the episode, title of the episode, authors of the episode, and also the MP3 file, a link to the MP3 file. So this is what other podcast platforms will take from this RSS feed to understand when they have new podcasts. And FFmpeg, FFmpeg is going to be used to merge the MP3 files. You remember I was talking about chunks of big, large MP3 files when we have a long podcast. So FFmpeg does a great job of concatenating these files. So far, we only worked on pretty normal length podcasts, 30, 40 minutes, and they all fit into one file. But if a podcast, let's say, lasts for 1 hour, 30 minutes, it's pretty much guaranteed that you will not have one chunk, but you will have multiple chunks, and you will have to merge them. We don't do that yet, but it's in our plans. So yeah, just a bit more about fetching podcast metadata and audio from somewhere, and we use podcastindex.org to download all the related information from them. So we download the title, description, publish date for audio file location, and also some additional metadata, which we are sometimes interested in, sometimes we are not interested in. And this data may include, for example, I don't know, copyrights or something else. It's not very important to us right now. And this is the first step, when we download this data. And the second step is to download the actual MP3 file and work on it. And this JSON which we download contains a link to the MP3 file, so we just download it and work on it. The transcription process. Transcription process is when we take the MP3 file and produce the text from it, and we use Whisper1 API to do this, to take the audio and convert to English text. We use English as an intermediate language, and yeah, so mainly podcasts are recorded in English, and we decided to start with English so that it converts it to English. It produces this English text. Works well for most recordings under 25 megabytes, and it's I would say about 40 minutes of a podcast, sometimes even more. And yes, if you have longer episodes, then we will have multiple chunks um, of this text, but it's pretty easy to just merge them. So, but in the end, if you have a long text after all these manipulations, and you want to produce an audio file, you have to split it into chunks, and you split them, you then merge them, and it's just a matter of a few days of work actually, but it's not very important right now. Improving translation transcription using GPT-4o. So here you can see a little bit of the prompt, a simplified actually prompt, that we use to translate the podcast to English. So we take the initial podcast, we take the text from it, then there are two possible options, three I would say. The first one is the ideal option when we have just English podcast and with just English speech. Second case is when we have English podcast with some other language somewhere in it. Let's say, I don't know, French phrases in this podcast, which we want to translate to a single language. And the third case is when we have the podcast in some other language, any language, French, for example. In any of these cases, first step is to translate everything to English and then work with English text, and only after that we will translate it to the final language. So yeah, in this I will just read it. So context, this is transcription of a podcast in some language. Fix the grammar and punctuation or translate it to English or source language. We have English for now. It's in the wrong language. The text where podcast starts and cut unrelated content at start. Yes, so there might be a very beginning part of the podcast which we're not interested in. It's mainly the part when authors of the podcast introduce themselves, talk about what they are going to talk about in this podcast. Most of the times it's not important, and we just cut it and go straight to the main topic. And as an input, we give the transcription of the podcast. The next step, so we use Russian language as a target language, and here you can see also a part of the prompt which we use to translate the podcast to the final language, and it says translate text below to the Russian language. Keep the translation as close to original in tone and style as you can, so that this part says that we want to keep the jokes, keep the tone, keep everything we had in the original podcast in the final podcast, and we pass the text from the previous stage. Next up is converting text to speech. So how it happens, we have this Russian text and we pass it to TTS1 model. It generates us the MP3 file with the speech, and we can use it after that. It's that easy. It's just one parameter to this model and it returns you the audio file. There are multiple challenges with it. First one is that we have limited voice options, and so for OpenAI there are a few voices that you can use, but not really many. The one we use has slight American accent, and it's actually there are better voices for Russian, but we use it because then listeners can hear that this is not the native language for the author. This is a translated podcast, and if your speech has slight American accent but it is in Russian, then you will understand that it's not what the author was saying by themselves, but rather it was something translated. Or it can also be the case that the author says this by themselves, but with the American accent because he's not native in Russian. And as an example here, we have a little sentence from a podcast. A Love the Nature podcast host gets an upbeat TTS1 voice saying "Здравствуйте" with a slight American twang. So I wouldn't replicate it because there are not many Russian listeners here, I believe, but it will sound like you don't speak English, but you speak some other language, and but you no sorry. It will sound like you have your mother tongue is English, but in another language you sound a bit non-native, right? Now let's move on a bit. Overcoming technical hurdles, file size limits in Whisper. So if we have a very long podcast, a very long text to translate it to speech, then we will need to split it by chunks, child by chunk. And the more difficult part here is not just splitting them, but is to understand where we want to split them, because you don't want to split them in just in the middle or somewhere like that, because then you will probably cut in the middle of a word, or even if not, then in the middle of a sentence. You don't want that. You want to keep sentences clear. You want to keep them in the single part. So the idea that we can use, that we want to use, is to split this text into not just sentences but like paragraphs, where we talk about one thing, then another thing, and so on, and then we can translate these parts one by one, and they will not hit the size limits for Whisper model. The next problem, hurdle, is style preservation and translation, and by that it means that even if we say to ChatGPT, to their model, that we want to preserve the style, we want to preserve the tone, it's not always possible, because different languages work differently, and you just cannot have the same kind of style into different languages. At least like 100% you can have it. You can have parts of it, you can translate jokes, you can translate some context, but not everything. And the third problem is audio merging complexities. I was already talking about that. Now let's move. Audio merging challenges. So why the exact reason why we cannot take multiple MP3 files and join them together is because we will lose some metadata. And this is a problem because if you want to play the podcast not from the beginning, but from the middle, then some players can just break, because they will think that this audio file, well, they will read the metadata description in the beginning from the file, and it will say, for example, that it lasts for 15 minutes. But actually, you have 3 chunks merged together, each lasts for 15 minutes, so the whole podcast lasts for 45 minutes. And when we try to scroll to, let's say, in middle, the player might think that, well, the middle of 15 minutes is like 7:30, and it will move to 7:30 instead of like 45 divided by 2, whatever it is, like 22.5, 22.7 minutes, doesn't matter. So it can create playback issues, but if we use FFmpeg for that, for merging the files, it will update this metadata and everything will work smoothly. And yes, in the middle you can see that current method works but breaks seeking, and the current method for us is to just join these MP3 files together, just byte by byte. It's not perfect, but it works. Optimizing GPT for author translation. So how we use it? We use it first to correct the grammar, And again, this is used to take the sentences and drop unfinished sentences.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi everyone and welcome back. I forgot to switch on my lights. Hi everyone and welcome back to Software Architecture Conference. The previous session was recording, because the speaker couldn't join us at the very last moment. But I'm really excited for the next session because the next session is about caching, payloads, and other dark arts. Ooh, dark arts. It's about the front-end engineers. If you are a front-end engineer, you're gonna love this session because joining us is Faris, who is a front-end engineer, mentor, conference speaker, and a workshop instructor. And these days, I see him going to so many events, speaking. He's a for real rock star. I remember I hosted him last year, right? He was a low key then, right? He used to speak at conference, but now, my goodness, with the conferences happening in Europe all over, he's everywhere. So let's bring him in. Hi, Faris, and welcome to the Software Architecture Conference.
I can't believe it's been a whole year.
We have gotten old.
To be back. I know I've gotten old. I've got a couple of gray hairs now, but hopefully I've gone through a couple more battles that we can learn from and all these different dark arts that we get to explore to improve a front-end engineer's journey. So I'm really excited about that.
Yeah, we all are too far. So I'm not going to take any more of your time. I'm going to add your slide to the stream. Everybody else can see it, and the floor is all yours.
All right, awesome. So I got that wonderful introduction. I need to say not much more about the title, but it is about caching, payloads, and other dark arts. And I'm a front-end engineer at heart, so we're going to be seeing this through the lens of a front-end engineer. So I already got a great introduction, but just a little bit about myself. I'm a staff front-end engineer at a company called Small PDF. So if you've done a couple of things with a PDF on the internet, like merging it, compressing it, Small PDF is a pretty cool tool that lets you do that. I previously was an engineering manager at a company called Navro, which was a fintech. And then, yes, I also speak at a couple of conferences here and there. Like this year, I'm going to be speaking at JS Nation in the US and React Summit in New York. And I teach a couple of workshops about resilient architectures, observability, and building performant React applications. Really love everything around the world of monetization growth, fitness technology, and web performance and engineering leadership. And if anyone here has ever used Raycast, absolutely love it. If you haven't used Raycast, it's finally actually available on Windows and on iOS, I think, too. It's a really, really cool tool for productivity. And I've built a couple of extensions there and love contributing to the open source world. And then I love the communities. So it would be a little bit of a shame if I didn't organize one too. And I'm based in Geneva, but I actually organized the Zurich JS community, which is the JavaScript community in the Swiss-German region. So if you're ever passing around over there, there's some pretty cool things that we do. Next, I think in September, we're hosting an event with Cloudflare and Stripe just before AWS Summit in Zurich. But enough about that. How I like to start my talks is a little bit with setting the stage. I think context is really important when it comes to software engineering. Like if you ever read a one-liner Jira ticket, sometimes you're questioning like, what's the context behind this, the requirements, the limitations. And so everything around architecture, there needs to be a bit of a stage that's set when you're having a conversation. And so the first thing is that there is no one size that fits all. The solutions and the conversations that we're going to be having today around the problem space is not going to be something you can just copy and paste into your own solutions. We all have our own unique requirements, our unique projects, or unique contexts. Some projects may be using the latest Next.js in the app router. Some may be just entirely single-page applications on React. And if you're still working on a vanilla JavaScript project, I wish you the best of luck. Then we're also not building a full-fledged application in today's talk, but more focusing on concepts and patterns that are agnostic that you can apply across multiple different libraries and frameworks. They're not just locking you down to the libraries that we're going to be presenting today. And then, yeah, these are really important libraries. These are really important patterns that we're implementing, but there is such a thing as premature optimization. A story that I like to tell a little bit with this one is that once I was consulting for a company in the US, and they were building one of the most beautiful Datadog dashboards I had ever seen, like a really incredible suite of observability tools to be able to detect, when things go wrong. And when I asked the question of how many users do you have, or you projected to have the next couple of months, the answer was 0 today and 0 in the next couple of weeks and months. And so if you're optimizing for a problem case that doesn't exist, you're not necessarily spending your time in the best place. And so that's something really important to consider, because we'll be looking through how to progressively enhance an architecture today around problem space. But what is the problem space that we're going to be looking at today? The problem statement really is, what challenges do developers face, specifically front-end developers, in creating a seamless user experience due to complex data fetching and management? Something we pretty frequently do. We have to fetch data from APIs. But I'd like to rephrase this problem statement a little bit around, how can we actually build optimal solutions in suboptimal conditions? We are generally told, from an engineering perspective, like, how do I build things if everything's working perfectly? But not everything works perfectly all the time. I travel to a lot of conferences, and so very often I'm using my phone and connected to websites while I'm on the train, and the train enters the tunnel, and then something disconnects. Or I'm operating on a plane Wi-Fi and there's limited bandwidth. And so your websites are being built in optimal conditions, which is your localhost environment on your latest M4 MacBook with the Ethernet connection, and seldom being used in that same environment. So it's important to also figure out, how do we build optimal solutions in those conditions that aren't the ones that we're building in. And then there's that question around, why bother? Now, websites loading in the first 0 to 2 seconds is really crucial for user satisfaction. That is considered the gold window for conversion. I think there was a study done in around 2006 by Amazon that just an increase in 100 milliseconds of their website load lost 1% of their sales, which the amount of revenue that Amazon makes, that's a lot of money. And so being able to actually cut down on how long it takes for something to at least be interactive or visible for a user can make a major difference. Like, I even know myself, I don't want to be using a website that takes a long time to load. It's very frustrating. And in part of that, like, there's a 32% bounce rate increase probability as page loads go from 1 to 3 seconds. And that just continues getting worse. If it goes from 1 to 10 seconds, you're looking at a probable bounce rate increase to 123%. And that's no small number. And there's a little small thing here, that magic number that I'm showing you right now, that little dark art that we're going to start digging into, which is 14, the number 14. And if you've ever heard about the number 14 and when it comes to network requests, what's really interesting is that 14 kilobytes can actually load much faster than 15 kilobytes, maybe 612 milliseconds faster at times. And then the difference between 15 and 16 kilobytes is, sometimes negligible, it's trivial. And what's interesting about the number 14 is that it fits within a single TCP packet, minimizing round trips. And there's a little, a graphic that I like to show how to explain this idea. So you want to see a website.com. And if it's 14 kilobytes the size of it, or even that's just a singular network request, a JSON network request, or that's all the HTML for your website, one round trip happens and you've got everything loaded, and that's perfect. That's one TCP round trip. If you've got a 15 kilobyte website, you want to see that same website, what you get is the first 14 kilobytes, then you have to check if there's any more information, then you get the final kilobyte. So 2 trips are being made to get the entirety of that information. And so that's really interesting when you're looking at, websites or platforms like Twitter X. If you ever open up the Twitter X homepage and you look at the waterfall of network requests, you'll actually see that over 300 requests are made. Now that varies between Java static assets like JavaScript, CSS, fonts, icons, all that stuff that helps make a beautiful user interface. But then a bunch of those are asynchronous requests for JSON data to maybe populate your profile or your timeline and other things like that. And so every single one of those requests come under that same idea of if they're under 14 kilobytes, it actually makes a really big difference. And we'll actually explore how this works with a little bit of a problem that I faced when building a fintech dashboard. So a little bit about the technologies that we're going to talk about today. If React is the library, then Next.js is the framework. So I think even the React docs these days recommends Next.js as the standard framework to use instead of just create React app. And so if you never explored Next.js before, what's really cool about it is that you've got all this baked-in rendering strategies where you can choose entire server-side rendering, pre-rendering pages on the server and fetching data on the server. You can do static site generation, which is really great for content-based websites. Everything's file-based routing, so you don't need to mess with things like React Router or Tanstack Router. And then you've got API routes, so it acts as a full stack framework. So you're able to create really quick, serverless functions that you can call and run stuff in. And then there's also Tanstack Query that we're going to talk about, which is a powerful asynchronous state management library. And the reason I break that down a little bit is that sometimes when people are introduced to Tanstack Query, they think that it's a data fetching library, which is not entirely the case. It is a powerful asynchronous state management library. The asynchronous part of it is really interesting because data fetching is the most common asynchronous task that we do, but it's not the only asynchronous task that exists. And so Tanstack Query can be plugged into multiple things that are asynchronous, not just data fetching. It is in reality actually a state management library. And so while it can be used in combination with Redux or Recall, other state management libraries, it can in its entirety be used as a global state management library. And it's really powerful for a subset of things, which is like automatic caching and background updates, which is something really difficult to do. Optimistic updates. So if you have an editable table, for example, you're trying to make a change, you don't want to wait for that round trip of the API to come back and tell things were successful to update the UI. So optimistic updates can be really powerful. And then rolling those back if things go wrong. Pagination and infinite loading. If you've ever gone to Stripe docs and you just keep on scrolling and scrolling, infinite loading is a popular pattern these days. And then also being able to prefetch data before seeing it, so you can actually rapidly switch to a new UI and have data loaded. Prefetching can be really powerful, especially in paginated views, where if I'm seeing page 1 of a table, but then I want to go to page 2, you're already prefetching the next page. And if I switch to page 2, you're already prefetching page 3. So that's really cool. And then also being able to invalidate queries. So if I have a form that I'm submitting, maybe creating a transaction in a financial dashboard, and then I invalidate the list of transactions when I create a new one, just that it fetches the list and I have my latest one in there. So it helps you keep your data fresh and in sync. Now, these are the technologies or the language that we're going to be communicating with, but these patterns that we're going to be discovering in a little bit aren't just locked down to these frameworks and libraries. They just so happen to be how we're implemented them in this case. So we talked about a little bit of fetching from APIs, but there's not just a singular type of API, in my opinion. And when we talk about different API types, I'm not talking about REST APIs versus GraphQL APIs. I'm actually talking about the different types of APIs when it comes to public APIs or versus internal APIs. So a public API, maybe the Star Wars API, or there's even the Pokemon API. These are public APIs that you're able to access, and they generally respect, breaking changes rules, or maybe they don't. Maybe they use semantic versioning, but they're generally APIs that are not in your control. They're APIs that you may be rate limited for, because if they're public and they don't require authentication or tokens to get access to, they're subject to attacks, and so they want to avoid that happening. Then there are internal APIs where you are a front-end team, and then you also have a back-end team in your organization, and so you're able to, if you need a new endpoint, just call up your backend engineer, say, I need a new endpoint for X, Y, and Z, and then they build that up. And maybe you don't need open API specs to go around with that. Maybe there's no semantic versioning. You just have your backends designed for your front ends, and there are no external consumers besides the consumption of the APIs that happen within the product itself. And then you have partner and product APIs, and they're solely designed for third-party usage. So maybe you're in an API-first company, and so you happen to be building a front-end dashboard, but the API that it's accessing or using or consuming is an API that's also served as a product itself. So there are a lot of dependent users on it. Let's take, for example, Stripe, for example. Stripe builds an API that maybe its front-end dashboard consumes too, and then external users consume it too. So you can't just add new endpoints, switch up what the payloads look like. You've got to go through deprecation policies, and you have to make sure that you notify people 6 months in advance, so on and so forth. So there's a lot more complexity when it comes to changing the way those APIs work. And so when it comes to interacting with those different types of APIs, in my opinion, there are different scenarios, different considerations you have in terms of how easy it is to work with them or not. And we'll look at a scenario in which I faced with the tech team where this got a little bit tricky, especially with a partner product API. So we're going to start the story with bare bones data fetching. Whenever we're presented maybe with a Jira ticket or maybe a technical interview, you're kind of given a scenario, a couple of limitations, and you've got to build a solution for it. So this is a scenario that I was presented a couple of years ago, and this was at a fintech. So the scenario was our front-end team needs to design a dashboard chart that displays the distribution of the top 5,000 users in a system. So we're putting our product manager hats on. These are the requirements that have been given to us. This is something that we got to build. So we've got to display a front-end chart, build a front-end chart, and have a distribution of birthday for 5,000 users. So the first thing I'm doing maybe as a technical lead is I'm trying to figure out, okay, what do I need? I need to display a chart. I've got 5,000 users. These are different pieces of information that are going to change how I think about the problem. With every single problem, there are definitely limitations that come along with it. And so let's say in this case, the backend team's unable to provide a new endpoint or a data warehouse that returns required data in the format that the front end needs. And there's a limit of 1,000 users returned for each request. And so in this very real scenario, I was working at an API first company where I had to build a front end, but the backend team was building APIs that were servicing external clients. So I couldn't just have a new data warehouse popped up or a new endpoint that served my front end. I was limited by what was provided externally to clients to still build my internal solution. And so if you think about the scenario, again, 5,000 users, and I'm limited by my API by only querying 1,000 at a time. So, cogs start moving the head thinking about what we can do from a solutions perspective. Then you've got a data source, and the data is available via an API, which returns a list of users with all the data. So that's fantastic. At least an API provides the information that we need. So what may an initial bare bones architecture of this flow look like? And that's what we'll explore. So you've got your user interface, and the first problem we kind of face is that I've got 5,000 users that I need to display information for, but I can only fetch 1,000 at a time. So what one may reasonably go for is making 5 parallel API requests on the client side. And so I make those 5 parallel requests, and naturally you're showing a loading state in your user interface while you wait for those to get resolved. And luckily we're not making those sequentially. We can make those parallel quite easily on any front end. And there are 2 things that can happen. There's an unhappy path. And if there's an unhappy path, you tend to persist a loading state, and you may write some custom logic to retry things, either retry all requests or retry just the failed ones. And if you ever try to write your own retry logic, that can get really complex really fast, not to mention all the unit integration tests you would have to write around that to support it. And then you've got the happy path. So I receive all the data back. Got all this data that I need to merge together. I need to map it into a format that's suitable for me. I set it into state, and we're not talking about using any global state management libraries, just bare bones use state. I render the UI, and let's say that your state is suboptimally set up. Your state changes and dispatches are suboptimally set up. What may happen is that I click a completely irrelevant button or use a completely irrelevant piece of my user interface that may cause a state update that causes a refetch of all of those 5 requests. And then I may end up in a place where I start getting a 429 risk, or a risk of too many requests, and the API is going to tell me that it's not going to serve me anymore. And this is something that can quite common in a lot of scenarios. And what this may look like from a code perspective is that I've seen a lot of code bases which will use a use effect, which essentially has a set of dependencies that you react to, reactive dependencies. So if any state changes or component unmounts or remounts, it re-triggers this effect. And so one might create a use fetch data hook, which under the hood uses a use effect, so a reactive sort of system to be able to determine whether to start refetching or not. And so sometimes this reactivity can be a little bit sensitive and fetch information, not in cases where you don't necessarily want it to be refetched. So what this may look like again is you have use fetch data, then you're running some sort of a function to get the fake data. In this scenario, we're using a faker API to create fake data. We're saying how many requests we want to make, and then we're going to start mapping the data on the client side. So we're going to get the birthdays by month from the response, and then we're going to map that chart data into a structure that works for maybe chart.js or whatever library you're using, and then we're going to set that into state. So we have the data that we need to be able to present things in that chart. So let's look at an initial demo and see how does this actually flow in our user interface. So I worked with some really high caliber designers to create this UI. So please enjoy all of it. But what you're seeing over here is that we loaded the page. We're making 5 requests. And if we open up the network tab and refresh things, you'll see that indeed we do make 5 parallel requests. And that's what's happening. And this loading time is taking awfully long. You can see each request, even though they remain in parallel, is taking its sweet time to get resolved. And if we also look inside the payload, inside the data, you'll see that we're receiving a massive object for every single user, like latitude, longitude, bio, phone number, profile picture, a lot of information that, in fact, we're not using for the chart. So it seems like because we couldn't tell our backend team to adjust the payload, it seems like we're getting a lot more than we bargained for. And if you saw that last part, I'm going to replay it a little bit, is that the reason I put this hide button and show button was to kind of demonstrate how something that may be irrelevant between a hide and a show, maybe the data hadn't changed whatsoever, it's refetching all 5 requests. And so that can be an inefficiency that comes from any type of state management in a complex application. And that's something we'd want to avoid. So moving forward, if you had looked in those network requests and seen the payload, and if you add all of that together, that's 2.3 megabyte payload. And that's massive. That's a lot bigger than our 14 kilobytes that we were talking about a little bit earlier. And if we actually look at the data, a lot of that data was redundant. A lot of the data was data that we were not going to use. It's actually 73% of the data was stuff that we just don't need to use. And so how are we going to work towards making this a little bit more efficient? So a couple of key factors to create a summary of the initial implementation of this. So we created a custom retry. So a little drawbacks to that is that it needs testing, it needs maintenance, it's subject to bugs. Why do we want to reinvent the wheel? We've got no caching out of the box. Data mapping effort is done on the client side. So if you're used to throwing your use callbacks, your use memos together, there's a high chance you're going to be using that when you're doing all this effort on the client side. And then it's complex to manage state globally and sync it with data staleness. So you have this fragility of the reactivity that may mean you're fetching information when you don't necessarily need it. And then the payload is not optimized for state or for caching, which is a little bit unfortunate. So this is where I like to introduce the backend for frontend pattern, the BFF pattern. Specifically, out of the variants of this pattern, there's the transformation bridge and the aggregation proxy. What's really nice about this is that it's a pattern that allows you to empower front-end engineers, especially if you're using something like Next.js or even if you're using Astro, to be able to design these middle pieces, these backend for front-ends, these middle services that are acting as proxies to be able to adapt the backend data into whatever you need for the front end, instead of making all the requests on the front end side and then being subject to having especially large payloads. Where this is also really interesting is that if you have multiple front ends, let's say I have a mobile front end, a TV front end, and a web front end, and they all need that chart data. So being able to create this singular proxy that serves multiple front ends also reduces a lot of effort in terms of duplicating that logic. And then you have, of course, that decoupling of concerns, and you're able to start optimizing performance, because even if you want to have a front-end team of 4 people where 2 work on the UI and then 2 work on optimizing the proxy, switching up the data structures or whatever you need to do, maybe spinning up multiple threads to be able to process that data, whatever it may be, that also can sometimes make it easier from a team management perspective. And so we take this massive payload that we were seeing before and we just shrink it into the minimal viable payload that we actually need to receive on the front end. Maybe I just need the first name, last name, date of birth. That seems pretty reasonable. And so now, what may this new world look like when we're evolving this architecture? Now, instead of making those 5 parallel requests on the front end, what you may do is you may make one singular API request from to a Next.js handler. which is this proxy, this serverless function that exists. And it can be a Node.js microservice. It can be any proxy in any language or any way that you want to design it. It just so happens to be really easy to do with Next.js. Then you have that same loading state that we produce on the front end. You can go through the unhappy path where you fail, return error code, and you go through that same retry pane with that custom logic that you've built. Or you can go down the happy path where you receive back the data on that proxy level. You do the mapping data on the servers at the proxy level, and you're only sending the minimum amount that you need to the client. Now, you still send that data to the client. You set it into state, you render the UI, and you're still subject to that reactivity fragility. And so you can still get into a case where then you hit the 429 because you're making the one request that makes the 5, and you get into that loop of doom, so to speak. Now, what would that new fetch function look like when we shrink it and hit the proxy? We're just going to fetch, hit the proxy, and then the proxy is dealing with all the data mapping. So any of that logic you have done on the front end, you just migrate that over to that proxy level. And so what are some key factors of improvement that we've done in this progression of that architecture? So first thing we've done is failure isolation. Dealing with the multiple parallel requests is quite complicated in terms of determining when the next one retries, kicks off, if you do all of them one at a time. So you're isolating the failures to a single client request, so the client's only responsible for dealing with that one request, and the backend proxy can do whatever it wants to. You have a clearer separation of concerns in terms of code-based management, especially if you're serving multiple clients. And then the data mapping's done on the proxy level, which means that you can optimize as much as you want, but not only that, you're able to only send the minimum you need to the front end, which makes a massive difference. And we're going to actually already see in demo 2 how quickly we're able to get a loading to happen. So you can see it's a little bit faster already than the first iteration when we saw the demo, just because we're reducing that payload. So we're hitting that faker proxy and saying how much quantity we want, and we're returning a structure which is exactly suitable for the props that we're going to be sending to our chart. So we're not even just reducing the amount of data that for every single user object, we're actually already mapping it into what the chart's going to receive, which is an even smaller structure. And now we've actually moved that 2.3 megabyte payload over into a 666 byte payload. And that's a 99.9% payload reduction. Now, I'm not going to say things like if you copy and paste a solution, everyone creates a BFF, you're going to have a 99% performance improvement everywhere. But it's the idea that you're restricting and segregating out the data. Maybe it's multiple requests, multiple proxies that you're making. Maybe you have a separation of APIs dependent on domains via different proxies. There's a lot that you can do to manipulate how quickly something resolves rather than throwing it all into a singular request. And there's another interesting aspect to that. And so if we look at from a network bandwidth perspective, and we talked about suboptimal conditions, right now I'm connected to Wi-Fi, and let's say I've got 90 megabits per second, my download time is going to be 210 milliseconds for that 2.3 megabytes, which was that initial payload, the initial 5 requests that we were making, which is not too bad. It's not horrible. But then if we go move over to a 4G connection that goes to 760 milliseconds, and then move to a 3G connection, where if you're operating in countries like small PDF operates in developing countries, so you're not always going to get even a 4G connection, you're going to be limited to 3G connections. It's still a decent chunk of the world that operates with low network bandwidths. 9.5 seconds is just unbearable for something to load. And so if we already look into seeing how much of improvement is made by shifting that payload down to 660 bytes, on a Wi-Fi connection, it's blazing fast, not even a singular millisecond. And moving all the way down to 3G, so 2 megabits per second, your download time is still sub 10 milliseconds, which is a 99% improvement in terms of loading time. But even moving beyond that, because now you're going to be using a proxy, essentially, whether it's a Node.js microservice or whatever you're using to do that, there are a couple of advantages that come there too. So to talk about those advantages, you have to dig a little bit into ingress and egress. If you don't know what ingress and egress is data coming into a system or network, and egress is data coming out of a system and network. And if you're dealing with, edge functions that you're creating or serverless functions or whatever, this is really important to understand when you're deploying things to the cloud, like what's the data coming in, what's the data coming out, because that also has an effect in terms of cost. So what's the cost of implementing a solution like this? And when it comes to ingress and egress, there are also function as services and infrastructure services. So your function of services is going to be your AWS Lambdas, your virtual edge functions, your Cloudflare workers, and your infrastructure services is going to be your AWS EC2s, your GCP computes, maybe your monolithic backends that you're deploying there rather than your smaller, leaner functions. And so while it's very hard to calculate what the ingress bandwidth is across these, you can typically expect, an ingress bandwidth of 1 to 5 gigabits per second for functions and services, and then 2 to 25 for infrastructure services. And you are subject with functions as a service to a little bit of the cold start times that may have a little bit of an impact on performance, but typically they stay hot for a long period of time. So depending on your application, the consumption of those services, that may be something that you consider or not. But what gets very interesting over here is that if you're now using this proxy, while I can't guarantee the network bandwidth that I'm going to be using for my mobile device, whether I'm traveling through a train or whether I only have a 3G connection, you can almost guarantee a consistent bandwidth that your function as a service or infrastructure as a service is going to have. So the bulk of the payload and the bulk of the request that you're making at that proxy level is going to still resolve a lot faster from an ingress perspective. And then what you're shooting out of that, the egress that's coming over to your client, is going to be a lot smaller. So where you're having the unpredictable network bandwidth is where you're saving a lot on. And so you're introducing a little bit more guarantees into your system rather than having the bulk of the network requests being made on that client and putting all that pressure maybe on that mobile device. And so just if you look at this table a little bit, if you've got your infrastructure of a service and you had that large 2.3 megabyte payload, it'll take maybe 80 milliseconds. Infrastructure as a service, maybe 50 milliseconds. And if you were to double that, let's say our requirement increases at 10,000 users, 20,000 users, so on and so forth, the increase is not too bad. The increase is all the way for quadruple the data, almost 10 megabytes. You're going from 80 milliseconds to 320 milliseconds from a function as service perspective, which is much better than having loaded that directly onto the client, as we previously saw on the network bandwidth page. If you were to do that again on Wi-Fi and 4G for that 2.3 megabyte payload, yeah, for Wi-Fi, it's 205 milliseconds, which is not too bad. But even when you go to quadrupling the payload, you're at 820 milliseconds, which still becomes unbearable on a very high network bandwidth. So there's a lot to be said about how you can, put your data a little bit on a diet and reduce that payload to be able to actually take advantage of, these round trips that are being made and reducing it from a TCP network perspective. In comes then also then the other side of the story, which is TAN stack query. And I'm not going to go too much into it because there's beautiful documentation around it. And TAN stack query is not even on V3 anymore. It's all the way on V5. But there are a lot of things that it can do to also then reduce pressure on your proxy and on your backend in terms of how it manages making the asynchronous requests and managing the state. And so now if we were to involve TAN stack query in this story, or previously also known as React query, because TAN stack query can now be used across Angular or even vanilla JS projects, so like it's framework and library agnostic. What's really nice is that once you plug this in, is that you don't have to do any of that manual state loading or management. So you don't have to use state, set as loading, true, false, so on and so forth. React query handles managing the loading state. So when you're, making that single network request to your proxy, and then that proxy making the 5 network requests, React query is telling you when it's loading or not. So it takes control of that entire asynchronous process. Then when you enter that unhappy path on the server and you fail and return a code to the client, you don't have any retry logic that you need to write from a custom perspective or, test it at all. You can just enable either standard retries with TAN stack queries or standard retries 3 times, or with exponential backoff, which again makes a massive difference, because exponential backoff is, instead of retrying immediately after a request fails, exponential backoff allows you to wait, 1 second and then do a retry again. Then maybe wait 2 seconds after the second try, 3 seconds. So it allows a little bit of breathing time. And you can also implement jitters in there to avoid thundering herd problems, which is something that's quite interesting too. Then you also get yourself to a happy path where you map the data on the server, the same story as before, send the data to the client, and then you cache it, because TAN stack query allows you to cache, either in-memory caching or you can have persistent caching. And then React query derives the state from the response, and so you're plugging directly into TAN stack query to be able to get the data for the chart. And then there's something that we're actually fixing in all this process, where you render the UI. If a React state changes, what's going to happen is Tanstack Query is going to check the in-memory or offline cache and be like, hey, is this data stale or not? Do I need to refetch it? Maybe you set a stale time of 1 minute or 1 hour. If it hits the cache and it's all good, it just renders the UI again. No additional network requests are made. And if it misses the cache, and you can be very declarative about what it means to miss cache, because you can define a lot of different parameters, then it will start the journey again and making those requests. And then that gets really powerful because you're no longer subject to all that reactivity fragility. And so if we look a little bit about how this evolves our hook function in our React component, you're now using this hook that's exported by Tanstack Query called useQuery. You're defining query keys, which is generally your combination of your query parameters. And those are used to create hashes to store your cache. And it also allows you to store a cache per combination of different query parameters, because if your query parameters change, you want a new cache entry for what that data looks like, because the data may have changed as a result of that. And so that's something that's incredibly complex to implement from a manual perspective. And then there you define your stale times, being 60,000 milliseconds, and you're just passing query function, which is the asynchronous request that it's making. So just to wrap things up, because I know I'm slowly getting out of time, over here using a third-party library, and you're handing over a lot of stuff to that, so you don't have to test a lot of things, which means that you have a lot less code to maintain. You now have optimized things from a caching perspective, especially if you're doing offline caching. Like local storage has a limit of 4 megabytes, and so if you had the original structure making the multiple requests with all that data, you would run out of that local storage really quickly. You're limiting re-renders, and you have out-of-the-box configurable resilience. But we can take it one step further. And what I'd like to bring into the conversation is something around query criticality. And I'll then wrap this one up, and then I think things are a little bit towards the end. But query criticality is a little bit this idea that I like to bring, is that not every API request carries the same importance. So if you look at an API request, which is around authentication information, where you're getting your groups and scopes, that carries a lot more importance than the data for your chart and birthdays. I can live without that. And so maybe you want your front end to react differently. So if we look at the story now, and we're now changing things, and React Query actually allows you to start prefetching things in the server. This time, we're prefetching things on the server, and we're making the request for all the chart data on the server. And so what that allows us to do is pre-populate the HTML. And when you pre-populate the HTML, you have no data fetching to do on the front-end side. Everything is immediately, you can interact with everything immediately, and that makes the UI a lot more seamless. A little bit of a problem space you get into now with the fact that you're fetching things to the server is that you have a timeout that you need to put into place. Because what if that request from the server takes 1 second, 2 seconds, 3 seconds? Your user has zero interactivity because no HTML has been sent. Whereas on a single page application, you have initial HTML being sent, some JavaScript interactivity, and then the data is loaded later on. And so you can also implement timeout structures in place to make sure that if it takes longer than a second to fetch your data, bail that request and then try to recover on the client side. Because you use the query keys, Tanstack Query is able to say, hey, I tried making this request on the server side. I failed to do it. Let me recover the same thing. Or I already have a cache here that I've dehydrated because it was successful on the server. Don't bother making the request on the client side. So that's something that can also improve your user experience quite a bit. And when you're talking about critical and non-critical queries, if you're fetching multiple things on the server, it changes the way, in my opinion, how you would react to certain requests failing. Like if an authentication request failed, maybe you send them to a 500 page because you don't want any groups, the lack of group or scopes to give users access to pieces of your application that you don't want them to. Whereas the chart data, you don't care about bailing that. And so this is what the code may look like, and I'll share the slides later on, where you can prefetch data using this get server-side props, and you can define, and this is my own custom functionality, whether a query is optional or critical, and maybe you choose to either continue to render the UI and send the data to the server and let everything render from there, or if it's a critical query, you decide to just send the user to a 500 page and say that the server is not working because you don't want to risk any security issues. And so with all of that, you reduce UI delay and loading due to this prefetching. You actually do also a little bit of load balancing because you're doing a couple of requests on the backend side and then a couple on the front end side. So you're not putting so much pressure on the client again. Maybe they're using data roaming. You don't want to consume so much of that. you're starting to break requests in terms of their criticality, and you have strategies for data recovery. So in optimal scenarios, you're fetching as fast as possible on the server and pre-populating the HTML, and in suboptimal scenarios, you're recovering from that. And if you look at a final demo of how that looks like, you can actually see that when I refresh the page, there's no loading immediately. Immediately all the data is populated. And what I can do is I can go in the code and I can change the timeout. Originally we had a 2.5 second timeout, but if the request took longer than 500 milliseconds, what we did is we bailed and we made the request on the client side. What you saw previously was no request being made on the client side. And then when you change the timeout, you bail and you try to recover on the client side. And that's how you sort of design a progressive architecture where in optimal conditions, you have optimal results, and in suboptimal conditions, you still try to progressively have optimal results. And thank you for taking the time to listen to my talk. And if you want to have any feedback, don't hesitate to scan the QR code on the top right. If you want to connect with me on LinkedIn and have more questions, I know I blazed through it a little bit. And you're more than welcome to have the slides. I'll send them over. And I also have a couple of code bases that show how these things are built up with little demo playgrounds. And if you're interested in Zurich.js and ever popping around, don't hesitate to scan the QR code on the left side. Cool. Thank you for your time.
Wow, Faris, I really loved it. And I bet, everybody watching, it was a really fantastic session, and that you really went on a deep dive and, talked about the problems all of us face. And I especially enjoyed the part about backend for front-end layer, and how you handle tricky compliance issue with caching. And I would say thank you so much, for sharing all these hard lessons. I think it was a fantastic session. Let's take a few questions from the comments before we move to the next session. There's a question coming from Sakshi. She's asking, again, for backend for frontend. There's a question. Can you share more details on how you built the backend for frontend layer? Was it serverless function, a separate microservice, or something else?
It's entirely as you wish. So there's no restrictions when it comes to this. That's why we kind of dove into the infrastructure service for variant, which would be your microservice that you develop, or your function as a service, which would be your serverless function. So if you have your Next.js framework and you're creating these API routes, those get deployed as serverless functions. So that's the simplest way because you've got everything in one code base. And if your data mapping code is not too much, just keep it in one place. I wouldn't bother creating an entirely separate microservice just for 50 lines of code that are going to be doing some data mapping effort. If now you want to orchestrate multiple proxies in a monolithic fashion or create multiple microservices with templates, then it makes more sense. But if you only have to create one proxy, then take the path of least resistance. And there are very few drawbacks of going through one or the other, except for maybe a little bit of cost here and there. But it depends on the scale.
Wow, perfect. There's another question coming from Rohit. Again, it is about BFF. People love it. How do you ensure the resilience of your front-end application when the BFF layer itself could potentially fail? It's a good one.
Yeah, so I mean, it could fail for two reasons. It could fail due to the upstream errors in the sense that the backend service that the proxy is contacting fails, and in that sense, you would, depending on if you're happy with passing along the error, you'd pass along the error to the front end, and then Tanstack Query would handle the retries. If your proxy itself is down because you shipped code that broke it, or your serverless functions are just not functioning, your cloud providers are down for some reason, then that's where your exponential backoffs will help, depending on how long it takes for you to get back to a running cloud provider or a running service, if you're rolling back or so on and so forth. So if you're using exponential backoffs and you're not doing your retries immediately and you're waiting 1 second, 2 seconds, 3 seconds, you give your service breathing time to recover. And if it's anything other than a cloud provider not functioning and it's something got to do with your code, that you shipped something that broke a previously functioning version, either having something like Argo CD that does automatic rollbacks, or having a really robust observability system in place where you get alerts as soon as something like that happens, that'll also make a big difference, because you want to separately monitor your front end, your proxy, and your backend, so that you can also have end-to-end tracing to know what's the slowest part of that transaction, and then what's the part that errors out the most.
Wow. Faris, I know we are only 2 minutes into the next session, but, I think just like many of us will go back and rewatch your session. And I encourage everybody, there's so much you shared in just about 35 minutes, it was overwhelming for me, so I'm going to watch it in 0.75x, right? And take notes actually, right? So
Thank
Faris,
you
thank
so
you so
much.
much. Is there anything you want to plug in before we move to the next session?
No, I mean, if you search Faris Aziz or Faziz-Dev, you'll see all the upcoming conferences I'm doing. As I said, I'm doing JS Nation US and React Summit New York this year, and another like 5 or 6 conferences. I think I'm at What the Stack conference in September. So if anyone's there, just hit me up, and I'm happy to have a chat. But connect on LinkedIn, and see you guys soon.
Yeah, Faris, thank you so much. Thank you so much for accepting the session, and joining us today. We loved hosting you. Good luck with all those conferences. And
Thank
take
you.
care of yourself and see ya. Bye-bye. Have a nice day.
Bye.
All right, ladies and gentlemen, that was Faris for you. We now move to the next session. I know we're already 3 minutes in. So without any further ado, we're going to welcome Sakshi Naik, who's a data scientist specializing in AI and ML. And today she's going to talk about architecting resilience once again, right? Event-driven transformation behind Walgreens flu shot campaign. So let's welcome Sakshi. Before that, we play a short commercial.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi, Sakshi, and welcome to the conference. We don't see you. You have to switch on the camera.
Just give me a minute, please.
Yeah.
I don't know why my camera is not working.
Yeah, it was working. Yeah, I know that it was working. I know. So maybe you want to rejoin it, right? Sometimes.
Yeah, I would do that. That would really help.
All right, with that, ladies and gentlemen, by the time the speaker rejoins again, I was just looking at the comments. Thank you so much for joining in. Right, we have a lot of things going on. Right, recently we launched the Learn AI CSharpCorner. Right, you all will be receiving an email in next about 24 to 48 hours about the new thing that we have brought up. I think also the founder of CSharpCorner is joining us today, so I bet he's going to talk about that platform too. It's a place where you can actually go ahead and have instructor-led training. And with that said, we have Sakshi back with us. Hi, Sakshi. We now see you and welcome to the conference.
Hi. Thank you for welcoming. And this is such a great conference. The previous session was really a great one with a lot of information. I'm also going to watch it at 0.5. Okay. Let's get started.
All right, Sakshi, we won't take much of your time. Right? Please feel free to go ahead and share your screen. On the bottom of your screen, you will find a plus icon. Oh, so this is what happened with StreamYard, right? So speaker just, you end up switching clicking on that cross icon that is at the top, and then you close the StreamYard. It often happens. It happens with me almost every single time I try to stream it. Also, actually, it happens. You try to go somewhere, you click, and then the browser closes.
Welcome back. Yeah, I'm just trying to share my screen here. I'm trying to find the icon for the screen show. Yeah, got it. The present one, right?
Yeah.
Okay.
I'm really excited to learn about Walgreens flu shot campaign, what it is, and what did you all do with it? I
It
don't
was a
see you.
really exciting conference, and we had a lot of problems with the solutions that we were using previously. So it was great to actually change those solutions and do things in real time. Canva.
Yeah. And we have a lot of sessions coming up. What time is it at your place? Are you joining us from West Coast?
Oh no, that's from East Coast.
Okay.
I just got a new laptop yesterday, So I have to
Well,
personalize half the things. I'm so sorry about
on
it.
your laptop is still okay, but if you're moving from Windows to Mac or Mac to Windows,
Oh,
that's a
that is the
whole.
problem. I moved from Windows to Mac, and everything's
Oh,
opposite of what I was used. Everything on left is on the right. Everything on the right is on left. So
yeah, that happens. That
hard time
happens.
here.
Uh, I don't think I will ever leave Windows. You know, maybe
Mhm.
I'll use iPhone, but I don't think so. I'll ever quit Windows. I just love it. You know, those three buttons for the Mac, that's the red, yellow, and green or whatever. It just reminds me of traffic light, and I just don't like it having that.
I do not. Okay, finally.
You can, if you're on Canva, you can do a tap share, right, instead of full screen. Yeah, that
Mhm.
also works.
Okay. No, I'm just, my presentation is online. I'm just trying to log into the website to get my presentation.
Mm-hmm. Okay, no problem, no problem. If you want, we can take a minute break and then come back again while you do it.
Yeah, that's great. I would just come back.
Okay. All right, everyone. We'll see you in a minute's break. Oops, that didn't mean she had to drop, but never mind.
Welcome to
All right, welcome back, Sakshi. Were you able to share your screen?
Yeah, trying that.
But there's always day one, right? I still remember using StreamYard for the first time a few years back. All right, we see your screen. It's Canva.
Okay.
You want to go to the presentation mode. Perfect. I
Great.
already love the logo that you added. You know, it looks very nice.
Yeah.
All
Is
right,
there only
Sakshi,
on the
next
first
35.
page?
All right, Sakshi, I won't take much time. Next 35 minutes is
Mhm.
all yours.
Thank you so much. Good morning, everybody. Am I still audible?
You are loud and clear, Sakshi. Yes.
Okay, great. Hi, everybody. My name is Sakshi Naik. I am a tech consultant. I work at Walgreens and I have been in the field since around 10 years. I am a IEEE policy advocate. So I would like you to welcome to the Software Architecture 2025. Today, I will be diving into one of the problems which we faced at Walgreens. Walgreens used to use a sluggish monolithic system, which was not real time or scalable. So when we had a flu shot campaign, basically when Walgreens is a pharmacy for those of whom you don't know, and we offer services like obviously we offer medicines and we offer other medicinal drugs as well. But another thing that we offer in the retail chain is that you could come to the Walgreens pharmacy and get vaccinated, maybe for COVID, maybe for the booster shots, or maybe for the flu. So the flu shot campaign is something that we have seen the trends for the flu goes really high when it is the flu season, when it is near spring, when it is the fall season, when the allergies are on peak. So basically, we had a whole dedicated campaign just to make sure that when people do come for the flu shot, we are able to give them the flu shot, and not many people are aware that Walgreens does something like the flu shot, and we wanted to raise awareness for that and engage more users and enrich our customer base. So the problem was that we did not have resilience, we did not have speed, we did not have a system that could be scaled enough, and that's what we solved over here. So just imagine that it is the fall season, the flu season is peaking, and Walgreens, as I said, wanted to increase the uptake. We have 9,000 stores across USA, and we wanted to increase the uptake across each of those stores. The goal was to deliver localized real-time campaigns that respond to user behaviors like searching for flu shots or booking the flu shots or any regional health trend. And we also categorize this by zip codes. Our legacy system was a bottleneck. It was a monolithic Java app on a Teradata database, which processed data in nightly batch jobs. So we had jobs that ran at night, and it would take all the data from the Walgreens store for the last 24 hours, and then it would process it, and then it was available for further analysis. But the problem was that these batch jobs, one, it ran after the whole 24-hour day, so you're already 24 hours behind. Second, these batch jobs required 9 to 12 hours to process, so that is 24 hours plus 9 hours, or sometimes plus 12 hours. So you would have had a delay of 36 hours from when the customer actually visited the store to finally getting his data and analyzing it to make further decisions. So by the time we rolled out the campaign, the moment was past, the customers moved on, and obviously the marketing team was frustrated. So we needed a system that could act in minutes, not hours, not days, and we obviously wanted to scale them to handle millions of events all at one time to avoid the bottleneck issue. This is where event driven architecture powered by Apache Kafka was utilized. So why event driven architecture? Event driven architecture lets systems react to events in real time. Like when the user comes and clicks on, we also have an app, by the way. So if the user goes to the app and clicks on, say, okay, I want to have a flu shot today, in real time, the moment that he clicks is the moment that the data is getting generated and it is passed on to Walgreens and is available for analysis. We want this to happen within seconds. So the moment a user is clicking something like find flu shot, decoupling components for scalability and flexibility. For Walgreens, this meant ingesting events from apps, store systems, marketing platforms instantly, triggering geo-targeted campaigns based on behaviors and routing data asynchronously to personalization, analytics, and marketing systems. So personalization, analytics, and marketing are the three main core systems that we had in our pipeline, and we wanted to provide data to them constantly as and when the user came. We wanted to provide data to all of these systems continuously. So if you have dealt with slow batch systems, you would know that it drives the stakeholders crazy. They do not like to wait 36 hours to make the next decision, and that is exactly what Walgreens faced. EDA promised us speed, EDA promised us resiliency and the ability to scale. This is what transformed our architecture. So here you can see our architecture before and after. On the left is our legacy setup. That was a monolithic Java app which was tied to a Teradata database. It was running the jobs that I mentioned, the jobs that were running with a 6 to 12-hour delay after the 24 hours. This monolithic app was holding those jobs. It was very rigid, and just one failure could crash everything. And scaling meant scaling the entire monolith. So basically, if there is any problem in any event in the whole thing, even if one item is out of queue, or even if one item has a failure or any rejection because of the data or the nature of the data, the whole queue would just collapse. There was no rollback option for it, which was a very big problem. Second, I said we had 9,000 stores. So if you had to make any changes, you had to directly go for all the 9,000 stores. You couldn't go for each, you couldn't scale it as and when you wanted. So that was also a big problem. On the right is our new architecture. This is a microservices ecosystem with Apache Kafka as the event streaming backbone, and Snowflake was used for real-time decision making. We broke the monolith into services. So we assigned one service to each major team. So personalization got one microservice, campaign triggers got another, analytics got the third one, and each was independently scalable. So if we want to increase we want to scale the personalization item for any of those stores, we could do that without interacting with the analytics and the campaign triggers. Kafka streamed events between them, slashing latency to under 5 minutes. So the connectivity was so good, the latency reduced so much that instead of waiting for 12 hours or like first 24 hours and then afterwards for 12 hours, instead of waiting for so long, we hardly had to wait for 5 minutes. And this was like when the system was very raw. We had not actually polished it or optimized it or anything. We just had deployed it, and this was a major difference which we saw. So the shift was not just technical, it aligned engineering, marketing, and data science all in real time. I'll walk you now through the system flow step by step to see how Kafka powered this transformation. Apache Kafka is a distributed platform built for high throughput, fault tolerant event processing. So, as I mentioned in the monolithic app, the problem was that even when one item failed, everything could fail. So, this problem was solved by this new architecture wherein even something fails in, say, personalization, the analytics is still good to go. It is not impacting that part. First, so now, as you can see, the pipeline is there on the screen. So first are event producers like our mobile app, our store systems, our marketing platforms. They generated events. For example, when a user searched for a flu shot in the app, it sent a user search event with details like timestamp, his age, his zip code, and search term. Then the store systems sent inventory update events like vaccine stock levels. These producers wrote to Kafka topics like user search or store inventory or marketing event, which were partitioned across Kafka brokers for scalability. Next, Kafka topics acted as the central hub. Each topic was a log of events partitioned by region, like user search.east or user search.west, to handle millions of events. We used Avro schemas to define event structures, ensuring backward compatibility as we added fields like vaccination preferences. Then the consumers came in play. So the consumers, that is, our microservices like the personalization engine or the campaign trigger, subscribe to these topics via a pub sub model. For example, the personalization service read user search events to recommended stores, while the campaign service triggered emails on appointment intent events. Consumers ran in groups, so even if one failed, the other kept on processing. For resilience, we used dead letter queues to capture failed events like malformed data and implemented retries for transient errors. Replayable logs let us reprocess events for debugging or recovery. Finally, all of this was ingested by Snowflake for real time analytics like campaign performance by region. This flow, producers to topics to consumers, this enabled us to go from 6 to 12 hours to just under 5 minutes, delivering the campaigns that hit the mark. We were no longer waiting to react to an event that had already occurred 2 days ago. We were now acting in the moment. So now I'll explain how these components interacted with each other. Imagine a user in Chicago searches for a flu shot. The app sends a user search event to the user search topic in Kafka. This event includes the user's ID, zip code, timestamp, and serialized in Avro for schema consistency. The personalization service, a consumer group, reads this event and then goes and queries Snowflake for store availability in that zip code. It then sends a recommendation event back to Kafka, which the campaign service picks up to trigger a push notification like flu shots available nearby. This happens in under 5 minutes thanks to Kafka's low latency streaming. Meanwhile, the analytics service subscribes to the same user search topic to track search trends, feeding data in Snowflake for dashboards. If an event fails, say due to network glitch, it is routed to a dead letter queue where we analyze and retry it. This decoupled flow means that services can scale independently. For example, during flu outbreak, we scaled the campaign service without touching personalization. The pub-sub model also lets teams work autonomously. Marketing did not wait for engineering to deploy updates. Key to this was schema governance. We used a schema registry to manage Avro schema, ensuring new fields did not break existing customers. This made our system future-proof and adaptable. Now let's talk about the design patterns that powered this flow. First was event sourcing. We stored every user action like searches, bookings, everything as a sequence of events in Kafka. This gave us an audit trail and let us rebuild state like a user's journey if needed. Second was the pub-sub model. Kafka's publish-subscribe model decoupled producers from consumers. The app did not care who read its events, personalization, analytics, or marketing, could subscribe independently. This made our system very, very flexible. Third was eventual consistency. For campaign triggers, we did not immediate need consistency. A slight delay in analytics was fine as long as notifications went out fast because we wanted it to reach to the customers at the earliest. This trade-off let us scale without heavy synchronization overhead. These patterns made our system robust, handling millions of events across 9,000 stores without a glitch. With health data, security and observability are critical. For security, we use tokenized user data in events to protect PII like names or zip codes and used role-based access control on Kafka brokers. Only authorized services like personalization could read specific topics. We also ensured HIPAA compliance for a health data privacy. For monitoring, we used Kafka Connect to feed metrics into Prometheus and Grafana. Now we used Grafana, but later on we also moved to other dashboards. We also started leveraging the dashboards that were a part of Databricks. So we eventually removed Snowflake and moved out to Databricks, and then within Databricks we had a SQL Analytics workspace which can be utilized to create great dashboards. Plus Databricks data engineering workspace also gives you access to dashboards. So that was also done in the later stages. Before that, we used Kafka Connect to feed metrics into Prometheus. This showed consumer lag, message throughput, and error rates in real time. If a consumer lagged, we scale it up instantly. Observability was our lifeline. Without it, we would not be performing as well as we are doing right now. So what did all of this achieve? What were the business impacts? I mentioned that if your stakeholders have to wait for 36 hours to see what is happening or to make any analytical decisions, they just go crazy. They want to see it in the moment right now. And this is what they saw later on. And this is the business, and this is a business outcome, which was a measurable impact. The results were really huge. We saw a 45% lift in campaign conversions. This was by delivering hyper personalized triggers like reminders when users search for flu shots. Latency dropped from 6 to 12 hours to under 5 minutes. And once it was more optimized, it is now not even 5 minutes, it is just within seconds. This let us act on user behavior in real time. The architecture was reusable. So once we had built all of this, we could take all of this and just redeploy everything. For say now flu campaign is over, booster shot campaign is coming up, we can use exactly the same EDA pipelines over there. So this saved us a lot of money and saved us a lot of months of works. It unified teams, it unified engineering, marketing, data science, who collaborated around a shared data time model and broke it down into silos. The chart here shows the impact. Conversions jumped from 30 to 45%. Latency went from hours to minutes. This was not just a tech win, it really drove business value. So now, this was for Walgreens, but how can you benefit from this? What are your takeaways? So here are some lessons you can take home. First is start small. Pilot your EDA with one use case, like a single Kafka topic. We began with user searches and then scaled up. Second is schema governance. Use a schema registry to manage evolving data formats. It saved us from breaking changes. Monitoring is the third one. Track consumer lag and throughput. They are your early warning systems. And fourth, cross-functional bind. Align teams early. We held workshops to define the data model, avoiding friction later. These apply to any domain, healthcare, retail, or even beyond. So here there are two things that I really want to emphasize on. Schema governance is really very, 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 very important, because the data that we get in real time is never in a good format. It is always messy, it is always bad, things keep on changing. So if your application is not able to handle that, your architecture is not able to handle those data changes, and it's just very rigid, and even one change is going to break the entire thing, you will not be able to scale it up to industrial levels. So make sure you pay really good attention to the schema governance. Second thing is creating a system or deploying a system, designing a system comes under engineering. So a lot of people are really very interested in that, and as engineers we often feel that, okay, I want to create something, I want to solve a problem, and then I want to deploy it, and I want to see how it works in production, and then we move on to the next item. Okay, next project, next item, next problem statement. We do not invest as much time in monitoring the system, in maintaining the system. That is why brilliant systems also break down. When you are solving a problem statement, say in January, and when you are deploying the architecture, say in March, so maybe it is working properly in March for the problem statement you got in January. But now, if you do not maintain this project, if you do not maintain your architecture, and you just go to June, July, August, September, in September, you would see it's not performing as well as it should have been. Or you have missed critical things because you were not monitoring enough. That's okay. There are certain things that are happening. Users change constantly, their behaviors change constantly, and the way industries have to react to it also changes constantly. So one, you need to maintain your architecture, you need to see that it's not never down or anything. And second, you need to constantly track user behavior to see that, okay, has the user pattern changed, and do we need to react in a different manner? Does our architecture need to take something else into consideration? While doing this, I do not mean attack the privacy of a person, of the user. You can personalize his experience without causing any harm to the privacy. You can protect the privacy and still give a very enriched, personalized experience. So monitoring was also very important. We have had cases where we had this amazing system deployed, which is now just taking seconds, and we did not have a dashboard to monitor in real time what is really going on, and we have missed critical items. But once this monitoring system was set up, once we started monitoring through the Grafana dashboards and then slowly through the Databricks dashboards, we caught a lot of glitches, we caught a lot of changes in the user patterns, and it helped Walgreens a lot. The third thing is it's actually a soft skill item, but I think I should speak to all engineers over here. Please ensure that if you are deploying a project of this scale and you really want it to be successful, please ensure that all of the cross-functional teams are aligned on that. Everybody has the same vision. Everybody knows exactly in what kind of direction you are proceeding. Maybe it is the marketing team, maybe it is the data science team, maybe it is the AI team, maybe it is just the business analyst team, maybe it is the sales team who understands just numbers and they wouldn't get what technology is, maybe it is the product management team. Treat every team equally, take inputs from all of their teams to create a system, and make sure everybody knows where this is going. If you lock in your vision early and everybody chimes in properly, the success rate of your architectural project would really increase by a lot. Okay, so this is a template that we have built. So like I mentioned that once we did it for the flu shot, we did not really need to go and make a lot of changes for the booster shots or for the other vaccinations that we offer. We just could roll out the same campaign again and again on the same architecture using one blueprint. Of course, I cannot give all the details out here, but on a very high level, this is how a EDA blueprint actually looks like. So if you want to build your EDA, use partitioned Kafka topics like user events dot region for scalability. Set up consumer groups per service. Implement dead letter queues and retries for resilience. Again, I forgot to emphasize on this. The dead letter queue is also very important. The data that you get, a lot of it is failed events, a lot of it is rejected data, but it is not all noise. You can also find really good information and you can exploit it for getting more information, valuable information. So make sure that you do have the dead letter queue enabled. Yeah. And the third thing is deploy Kafka Connect plus Prometheus plus Grafana for monitoring. So this is what we did in the initial stages, where we used Kafka Connect with Prometheus and Grafana. You don't really need to use the same things, Prometheus plus Grafana. You can use anything else. But the point that I'm trying to make here is ensure that you are doing something with the monitoring systems and you are not neglecting it completely. So EDA transformed Walgreens campaigns. It turned a slow system into a real-time powerhouse. Kafka and microservices gave us a scalable, future-proof architecture. Our challenge was that we did not experiment enough with EDA. I would like to extend the same to you. If you're not experimenting enough with EDA, this would be a really good time to start a solo project maybe. And you could try a small Kafka project or explore tools like Red Panda. You could build the future of real systems together. And that was my story. So you can find me on LinkedIn or on YouTube on the same channel. If you have any other questions, I would also be uploading the same session on my YouTube channel. I am sure C# would be doing the same. I unfortunately do not have enough time to stick around for questions and I need to leave. But if you do have any questions, please send them to me on LinkedIn. I'm there on LinkedIn with the same name, Sakshi Naik. Or you can see the videos that I would be posting on Sakshi Naik. That's my YouTube channel. Thank you.
All right, Sakshi, thank you so much. I know, and it was a great session. I really, really loved, watching it from behind the scenes. I want you to take a rest, and maybe get yourself a glass of water, right?
Yeah.
With that said, I know you don't have much time. It's a work day, right? You have many meetings. If there's any questions, right? If you want to come back to the YouTube stream and answer them, perhaps maybe you can do that.
Yeah, we will do that.
Once again, want to thank you so much for being a part of this conference. Have a great day ahead, and let's stay in touch. Great session, by the way.
Thank you so much.
Thank you. Bye-bye.
Bye.
All right, ladies and gentlemen, that was Sakshi Naik. Unfortunately, we cannot take a lot of questions there because it's a weekday, right? And people have work to do. But before we move to the next session, I want to talk about the next session. Actually, of course, we got to talk about the next session before we talk about the next session. I don't know what I'm saying, but okay. All right. The next session is by Alexander. It's about process depth in real, how to refactor your engineering workflow. And ladies and gentlemen, mind it, and it's a recorded session because Alexander emailed me just 3 in the morning that he had something very urgent in his family, right? So he cannot show us today, but he was very kind to record the video and send it to us. So let's take a quick break, and after that, we will watch the Alexander session that's about process in depth, how to refactor your engineering workflow.
Hi everyone, I'm Alexander, and today we are going to talk about process depth and how to refactor your engineering workflow. This is a talk about architecture, just not the kind that lives in your code base. We are going to look at the architecture around your code, the workflows, rituals, and systems that decide whether your code ever ships. You might notice this pattern. You're shipping your changes more slowly. You might ask yourself, what's the reason behind it? You're a team of sharp, hardworking engineers. Everyone is in the meetings, responding to tickets, reviewing pull requests, but nothing is actually getting released. And progress feels slow. Shipping feels heavy. You look at the backlog and it just keeps growing. So you assume might be tech debt, right? The architecture must be messy or the code base too fragile. But when you dig in, you realize the problem isn't the code base, it's around it. It's not a code smell, it's system smell. Endless Jira tickets, Slack ping pong, review queues with no ownership, architectural friction just outside the code. This is what I call process debt, and it acts like tech debt, but in your delivery system. It's something that's harder to see, but just as harmful. It's a slow accumulation of inefficiencies in your engineering workflow. And just like bad architecture, it's invisible at first, but eventually it kills your ability to ship. We are going to break down what process debt look like, how to recognize it, and most importantly, how to refactor your workflow just like you would refactor your code. When we talk about architecture, we think about structure, about flow and efficiency. Well, the same rules apply to your engineering workflow. Let's define what we mean by process debt. Think of it as organizational cousin of technical debt. Just like tech debt happens when we take shortcuts in code, we are accumulating bugs, fragile logic, and legacy hacks. Process debt accumulates when we take shortcuts or make poor decisions in our ways of working. It shows up when we adopt rituals that no longer serve a purpose, when we patch our coordination issues with more meetings, or when no one knows who owns what because organization chart changed 6 months ago and no one ever updated the process. Here are a few examples of process debt. You have a stand-up every day that lasts 25 minutes, but no one finds it useful anymore. People attend it just out of obligation. Or, for example, pull request goes through 2 reviewers, then a tech lead, then another team who owns this code, even though 90% of these reviews are just stamps engineers do without even looking at the code. Or maybe you're unclear who owns the feature, so 3 people started and no one finishes it. That's another example of process debt. It's invisible at first, and that's the danger. Over time, it piles up, slowing velocity, killing morale, and leading engineers to say, why does everything take so long here? So if tech debt clogs the code, process debt clogs the culture. And just like tech debt, we need to identify it, we need to measure it and refactor it before it starts affecting our delivery. Now, let's talk about hidden costs, the symptoms of process debt. Symptoms that you might probably be feeling without even realizing the root cause of it. So you see teams that are constantly busy, but releases keep getting delayed. Why is that? Because they're spending time navigating the process instead of building the product. Or you might see duplicate work. The same issue solved twice and no one knows who owns a feature. This usually results from poor coordination or invisible handoffs. And then there is a classic when we say, oh, just check information like in Slack. That became a proxy for a broken workflow. When there is no defined process, Slack becomes a chaotic memory bank for institutional knowledge, and that's dangerous. But we actually can measure this pain. If you median cycle time goes from, let's say, 2 days to 6 days with no change in code complexity, that's the signal. Just like in system performance, latency spikes without increased load usually means inefficient pathways or some bottlenecks. Same with delivery latency. It's often a workflow bottleneck. It's blocked by unnecessary reviews, unclear approvals, or vague requirements. Throughput drops because teams are stuck in process overhead instead of shipping value. And maybe most importantly, morale drops. Engineers feel unproductive, disengaged, and confused. This leads to burnout or even worse, attrition. Now, here's a key point. This isn't technical debt. Technical debt lives in your code base, while process debt lives in your culture, your rituals, and your operations. So you can't refactor process debt with a pull request, but you can refactor it with intention, iteration, and visibility. So how does process debt even appear? It appears not because people are lazy or negligent. Actually, it's the opposite. Most process debt is born from good intentions. We introduced a meeting to improve communication, a checklist to prevent bugs, or sign-off to ensure alignment. But over time, these well-meaning steps accumulate and eventually become rigid and wasteful. First, legacy rituals like daily stand-ups that no one finds useful anymore, but no one questions. Or sprint demos that were helpful once, we introduced it, but now it feels just like theater. These rituals go unchallenged because they're ingrained and no one owns them. Second, over-collaboration and unclear roles. Have you ever been in a document with 8 commenters and no decision maker? That's a process problem. People don't trust the system, so they over-involve everyone just in case. Third, fragile tooling. We all work with tools that were supposed to streamline things, but instead they created extra steps, conflicting information, or got misused over time. And finally, additive thinking. Stakeholders keep adding layers to the process. Another review, another sign-off, but they would never subtract them. Because removing a process, it feels risky. And ironically, it's a build-up that creates this risk. As a result, the system that looks robust on paper, but in reality, it's fragile, slow, and it's draining. We've talked about what process debt is, but where exactly do you look for it? Let's use a simple framework with 4 high-leverage areas, such as meetings, handoffs, tools, and decision-making. Start with meeting. You might ask yourself, am I stuck in daily rituals that no longer serve their purpose? Stand-ups that run long, meetings that should have been an email, or too many people in the room. If that sounds familiar, that's an indication of a process debt. Next, handoffs. It's when work changes hands, say, from design to engineering or from backend to QA. Others transition crisp, or do they involve ping pong across Slack threads and unclear ownership? Every unclear handoff is a bottleneck. Third is tools. Not all tools are helpful. Sometimes we rely on tools to solve problems we created with other tools. Is your team suffering from context switching on fragmented knowledge because of too many overlapping systems? Teams often duct tape Jira, Confluence, Slack, Notion, creating fragmented knowledge systems with high context switching cost and no single source of truth. And finally, decision making. If your team has to pause and ask someone every time they hit a wall, there is a sign the decision process isn't clear or empowered. This silently adds latency to the process as well. Now, here the key moment I want you to reflect on. If your workflow was a code base, would you merge it into the production? Would you approve a pull request full of duplicated logic, vague ownership, untested path, and legacy functions nobody wants to touch? And the answer here is probably not. But that's exactly what many workflows look like. So, treat your process like you would treat bad code. Let's start diagnosing and eventually refactoring. One of the biggest challenges with process debt is that it's invisible until it hurts. Just like tech debt, you can't improve what you don't measure. Start by looking at quantitative signals. Is your pull request time increasing? Are tickets cycling through multiple hands without progress? Is each engineer juggling too many work items? These are all measurable friction points. But numbers alone don't tell the whole story. So complement them with quality-based signals as well, such as: what do your retros keep bringing up? How does your team feel about the process? Now, to make this practical, we can just build a metric. On this slide, it's called the process friction score. It's a simple weighted index you create internally to track how your workflow is trending, up or down. Think of it as your velocity temperature check. If you start rising, you've got process inflammation. We instinctively apply good software principles to code, but we rarely apply them to how we work. So first, don't repeat yourself. Many teams accidentally duplicate rituals. They have a daily stand-up, weekly check-in, bi-weekly sync, all covering the same ground. Consolidate them, pick one, do it well, eliminate the rest. Next, you ain't gonna need it. We often add process steps based on fear. More approvals, just in case, double tracking work into tools, or speculative backlog grooming. If it's not solving a current problem, just kill it. And finally, continuous integration of process. Just like CI in code, apply small testable changes to process frequently. Don't do a process redesign quarter. Instead, make one adjustment at a time, validate it, and iterate. This mindset turns the process from something heavy and painful into something lightweight, just like clean code. As we've seen, refactoring your engineering workflow can unlock huge improvements, right? But like code refactors, it's easy to go too far and unintentionally cause harm. Let's look at 3 most common mistakes teams make when they try to fix their processes. And the first is overcorrecting. Teams often swing the pendulum too hard. They go from daily stand-ups to not updates at all, from 3-step code review to no review. It feels freeing at first until things break down. You need to balance agility with structure. You remove friction gradually. You test changes like feature flags and monitor the impact. Second, it's cultural blindness. You can't impose the same workflow on every single team. A highly async team might benefit with written updates. A collocated team might rely on spontaneous conversation on Office Kitchen. If your changes don't respect how your team communicates, they'll get ignored or resisted. Successful process refactors are collaborative. They are not top-down. And third, tool obsession. It's tempting to think if we just switch to tool X, everything will improve. But tools are just enablers. They don't fix root behaviors. You can install the best project management system in the world, but if priorities are still unclear or meetings go unmanaged, nothing changes. Focus on behaviors first, then choose tools that support them. In short, treat your workflow refactor like a code migration. Go incrementally, test with real users, it's your team, and respect the environment you're shipping into. Now, that you have seen how to refactor broken workflows, the next challenge is keeping them healthy. Just like codebase, workflows doesn't stay clean on their own. They grow messy unless you actively maintain them. Let's talk about how to build a culture of workflow hygiene, one that helps prevent process debt from creeping back in. First, start with retrospective. Most teams focus on product issues or interpersonal dynamics, but rarely workflow itself. Built-in habit of discussing, did our process help or interfere? Look for signs of frictions. Long review times, confusion about ownership, meetings that feels like a waste. We can even include workflow audit in our retrospective agenda. This builds collective awareness and a permission structure to challenge the status quo. Second, empowerment of individual contributors. A lot of inefficiency is visible only at IC level, but teams often don't have safe and clear paths to raise these concerns. We need to normalize it, create Slack channels, suggestion forums, or any other lightweight way for engineers to give feedback. Make process feedback a first-class citizen, just like code feedback. Third, adopt what I call process pull requests. Think of this like pull request for how your team works. Small testable changes to workflow. For example, let's try async stand-ups for 2 weeks. Or let's cap work in progress at 3 tasks per engineer this sprint. Just like with code, you test the changes, review, and if it works, you merge it into your team practice. This makes the process change lightweight and iterative instead of scary and top-down. If you do all these 3 things, retrospective audits, empowering ICs, and lightweight process iteration, we'll move from one-time refactors to continuous process hygiene. And that's how you keep process debt from building up again. As an example, in one company I worked at, leadership tried to scale processes top-down across a few hundred engineers with the goal of standardization. They just came back from some fancy business training about how the best companies run engineering. So they rolled out a one-size-fits-all process model. But here's the issue that we just discussed. Teams are not identical. What works for one team might be completely useless for another. But now every team had to follow the same rituals, stand-ups, review rules, task workflows, even when those steps added zero value. Worse, these processes changes took months to implement. Huge coordination cost, countless meetings, tooling migrations, and by the time it finally rolled out, leadership found another new shiny framework and started the whole cycle again. So now instead of focusing on product impact or shipping the code, teams were focused on process for the sake of this process. And our discussion shifted from what features deliver value to what task tracker should we use this quarter. The process didn't help team deliver, it just added overhead. So in this example, organization did opposite to all three these practices. We need incremental changes driven by the team themselves. Extra steps, conflicting information, or got misused over time. And finally, additive thinking. Stakeholders keep adding layers to the process. Another review, another sign-off, but they would never subtract them. Because removing a process, it feels risky. And ironically, it's a build-up that creates this risk. As a result, the system that looks robust on paper, but in reality, it's fragile, slow, and it's draining. We've talked about what process depth is, but where exactly do you look for it? Let's use a simple framework with 4 high leverage areas, such as meetings, handoffs, tools, and decision making. Start with meeting. You might ask yourself, am I stuck in daily rituals that no longer serve their purpose? Stand-ups that run long, meetings that should have been an email, or too many people in the room. If that sounds familiar, that's an indication of a process depth. Next, handoffs. It's when work changes hands, say, from design to engineering or from backend to QA. Others transition crisp, or do they involve ping-pong across Slack threads and unclear ownership? Every unclear handoff is a bottleneck. Third is tools. Not all tools are helpful. Sometimes we rely on tools to solve problems we created with other tools. Is your team suffering from context switching on fragmented knowledge because of too many overlapping systems? Teams often duct tape Jira, Confluence, Slack, Notion, creating fragmented knowledge systems with high context switching cost and no single source of truth. And finally, decision making. If your team has to pause and ask someone every time they hit a wall, there is a sign the decision process isn't clear or empowered. This silently adds latency to the process as well. Now, here the key moments I want you to reflect on. If your workflow was a code base, would you merge it into the production? Would you approve a pull request full of duplicated logic, vague ownership, untested path, and legacy functions nobody wants to touch? And the answer here is probably not. But that's exactly what many workflows look like. So, treat your process like you would treat bad code. Let's start diagnosing and eventually refactoring. One of the biggest challenges with process debt is that it's invisible until it hurts. Just like tech debt, you can't improve what you don't measure. Start by looking at quantitative signals. Is your pull request time increasing? Are tickets cycling through multiple hands without progress? Is each engineer juggling too many work items? These are all measurable friction points. But numbers alone don't tell the whole story. So complement them with quality-based signals as well, such as what do your retros keep bringing up? How does your team feel about the process? Now, to make this practical, we can just build a metric. On this slide, it's called the process friction score. It's a simple weighted index you create internally to track how your workflow is trending, up or down. Think of it as your velocity temperature check. If it starts rising, you've got process inflammation. We instinctively apply good software principles to code, but we rarely apply them to how we work. So first, don't repeat yourself. Many teams accidentally duplicate rituals. They have a daily stand-up, weekly check-in, bi-weekly sync, all covering the same ground. Consolidate them, pick one, do it well, eliminate the rest. Next. You ain't gonna need it. We often add process steps based on fear. More approvals, just in case. Double tracking work into tools, or speculative backlog grooming. If it's not solving a current problem, just kill it. And finally, continuous integration of process. Just like CI in code, apply small testable changes to process frequently. Don't do a process redesign quarter. Instead, make one adjustment at a time, validate it, and iterate. This mindset turns the process from something heavy and painful into something lightweight, just like clean code. As we've seen, refactoring your engineering workflow can unlock huge improvements, right? But like code refactors, it's easy to go too far and unintentionally cause harm. Let's look at 3 most common mistakes teams make when they try to fix their processes. And the first is overcorrecting. Teams often swing the pendulum too hard. They go from daily stand-ups to not updates at all, from 3-step code review to no review. It feels freeing at first until things break down. You need to balance agility with structure. You remove friction gradually. You test changes like feature flags and monitor the impact. Second, it's cultural blindness. You can't impose the same workflow on every single team. A highly async team might benefit with written updates. A collocated team might rely on spontaneous conversation on Office Kitchen. If your changes don't respect how your team communicates, they'll get ignored or resisted. Successful process refactors are collaborative. They are not top-down. And third, tool obsession. It's tempting to think if we just switch to tool X, everything will improve. but tools are just enablers. They don't fix root behaviors. You can install the best project management system in the world, but if priorities are still unclear or meetings go unmanaged, nothing changes. Focus on behaviors first, then choose tools that support them. In short, treat your workflow refactor like a code migration. Go incrementally, test with real users, it's your team, and respect the environment you're shipping into. Now, that you have seen how to refactor broken workflows, the next challenge is keeping them healthy. Just like codebase, workflows doesn't stay clean on their own. They grow messy unless you actively maintain them. Let's talk about how to build a culture of workflow hygiene, one that helps prevent process debt from creeping back in. First, start with retrospective. Most teams focus on product issues or interpersonal dynamics, but rarely workflow itself. Built-in habit of discussing, did our process help or interfere? Look for signs of frictions. Long review times, confusion about ownership, meetings that feels like a waste. We can even include workflow audit in our retrospective agenda. This builds collective awareness and a permission structure to challenge the status quo. Second, empowerment of individual contributors. A lot of inefficiency is visible only at IC level, but teams often don't have safe and clear paths to raise these concerns. We need to normalize it, create Slack channels, suggestion forums, or any other lightweight way for engineers to give feedback. Make process feedback a first-class citizen, just like code feedback. Third, adopt what I call process pull requests. Think of this like pull request for how your team works. Small testable changes to workflow. For example, let's try async stand-ups for 2 weeks. Or let's cap work in progress at 3 tasks per engineer this sprint. Just like with code, you test the changes, review, and if it works, you merge it into your team practice. This makes the process change lightweight and iterative instead of scary and top-down. If you do all these 3 things, retrospective audits, empowering ICs, and lightweight process iteration, you'll move from one-time refactors to continuous process hygiene. And that's how you keep process debt from building up again. As an example, in one company I worked at, leadership tried to scale processes top-down across a few hundred engineers with the goal of standardization. They just came back from some fancy business training about how the best companies run engineering. So they rolled out a one-size-fits-all process model. But here's the issue that we just discussed. Teams are not identical. What works for one team might be completely useless for another. But now every team had to follow the same rituals, stand-ups, review rules, task workflows, even when those steps added zero value. Worse, these processes changes took months to implement. Huge coordination cost, countless meetings, tooling migrations, and by the time it finally rolled out, leadership found another new shiny framework and started the whole cycle again. So now instead of focusing on product impact or shipping the code, teams were focused on process for the sake of this process. And our discussion shifted from what features deliver value to what task tracker should we use this quota? The process didn't help team deliver, it just added overhead. So in this example, organization did opposite to all three these practices. We need incremental changes driven by the team themselves. Let's bring it all together. First, start with retrospective. Most teams focus on product issues or interpersonal dynamics, but rarely workflow itself. Built-in habit of discussing, did our process help or interfere? Look for signs of frictions. Long review times, confusion about ownership, meetings that feels like a waste. We can even include workflow audit in our retrospective agenda. This builds collective awareness and a permission structure to challenge the status quo. Second, empowerment of individual contributors. A lot of inefficiency is visible only at IC level, but teams often don't have safe and clear paths to raise these concerns. We need to normalize it, create Slack channels, suggestion forums, or any other lightweight way for engineers to give feedback. Make process feedback a first-class citizen, just like code feedback. Third, adopt what I call process pull requests. Think of this like pull request for how your team works. Small testable changes to workflow. For example, let's try async stand-ups for 2 weeks. Or let's cap work in progress at 3 tasks per engineer this sprint. Just like with code, you test the changes, review, and if it works, you merge it into your team practice. This makes the process change lightweight and iterative instead of scary and top-down. If you do all these 3 things, retrospective audits, empowering ICs, and lightweight process iteration, will move from one-time refactors to continuous process hygiene. And that's how you keep process debt from building up again. As an example, in one company I worked at, leadership tried to scale processes top-down across a few hundred engineers with the goal of standardization. They just came back from some fancy business training about how the best companies run engineering. So they rolled out a one-size-fits-all process model. But here's the issue that we just discussed. Teams are not identical. What works for one team might be completely useless for another. But now every team had to follow the same rituals, stand-ups, review rules, task workflows, even when those steps added zero value. Worse, these processes changes took months to implement. Huge coordination cost, countless meetings, tooling migrations, and by the time it finally rolled out, leadership found another new shiny framework and started the whole cycle again. So now instead of focusing on product impact or shipping the code, teams were focused on process for the sake of this process. And our discussion shifted from what features deliver value to what task tracker should we use this quota. The process didn't help team deliver, it just added overhead. So in this example, organization did opposite to all 3 these practices. We need incremental changes driven by the team themselves. Let's bring it all together. Process debt is real, just like tech debt. And like any debt, if you ignore it, it compounds. Think of your workflows as living systems. They aren't set once and forget. They grow, they degrade, and they need continuous refactoring to stay healthy. The good news is that you don't need to fix everything at once. Start with just one broken step in your workflow, one painful handoff, one meeting that adds no value, one review process that takes days. Refactor this step, measure the impact, and then move to the next. Architecture doesn't stop at your code base. You're also designing systems for collaboration, delivery, decision making. If your workflow was code, you'll probably refactor it. So don't wait until your process breaks. Treat it like any other system you care about. Observe it, test it, evolve it. Because scalable system needs more than clean code. It needs clean flow as well.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi, everyone, and welcome back to the Software Architecture Conference. This is the edition 4, and we're on day 1. We had some great sessions in today's morning, and we now move to the second half of the day, and we're starting the second half with the session that's on AI for Software Architects. And joining us today is Mahesh, who's the founder of CSharpCorner. Hi, Mahesh, and welcome to the Software Architecture Conference.
Thank you, Simon. Thank you. Amazing. Looks like this is going great. How's everything going?
Yeah, everything is pretty good. We had some great sessions today in the morning, and yeah, really looking forward for a very unique session that we don't have in all the 4 days, that is on AI for software architects. I won't take much of your time. I'm going to add your screen to the stream. Everybody else can see it, and next 35 minutes is all yours.
All right, guys, let's start it. Thank you, everybody, for joining. Looks like my slide is broken, but my name is Mahesh Chand. I'm today going to talk about AI for software architects. AI, I'm sure you have heard of this. It's here, it's everywhere, and we can't, skip it. Let's just say that. We have to use it in different ways, and it's a good and bad, right? It's good for, especially if you are always learning and adapting new technologies. AI is for you. AI is going to help you big time. And if you are a software architect or you want to become a software architect, what we will learn is how you can use AI to help you. So my background a little bit, my name is Mahesh Chand. I'm founder of CSharpCorner. I'm a published author, often speak at these conferences such as this one. Today we are going to talk about software architect, the person who is responsible for architecting software, and how this new AI can help, building better software and also boost your productivity as a software architect. So who is software architect? I'm sure you already know that. It's a person, it's a leader, it's technical leader who designs the architecture of a software, leads the team, also make sure that the product you're building, the software application or product or solution you're building, it is solving the business needs within the budget, delivering on time. So all the good things, the key person in charge of that is a software architect. Yeah. So in the meantime, if you have any questions about the session, about AI in general, just feel free to post your questions here. I am going to take your questions in the end of this session. I have a meeting at 1, so I will finish this 5 minutes earlier than I was supposed to. So I will go through maybe 20 minutes, talk about this, and then we'll take some questions. And feel free to ask any kind of questions you have. So AI, artificial intelligence, is a big field and it does a lot of things. There are different branches of it. When I'm saying AI for software architecture, it doesn't mean here that what are the different AIs are designed for software architecture. What I'm trying to explain is how AI can help you as a software architect to increase your productivity. And the AI that does help big time is generative AI. So AI has these different levels, and generative AI is a small portion of the whole big ecosystem of AI. Anything you see today, ChatGPT, Gemini, all these new coding tools, copilots, they all come under generative AI. That's a part that AI that deals with all this is called generative AI. And why it's generative? As it says, word says generative AI. So it's AI that generates, that creates. So AI that generates new content is generative AI. And how does that do it? How does it do it? So the brain behind the whole machine behind this whole generation of new content are these LLMs such as GPT. I'm sure you heard of OpenAI had GPT-4, GPT-3, GPT-1, all those. These are models. These are large language models. When you think of a large language models, think of it's a big system. And this system runs on multiple machines, supercomputers. It has vast amount of data. That data it has curated from all over the internet, from the books, textbooks, PDFs, documents, coding websites, everywhere it could find all that. So think of, when you think of a Google as a search engine, Google as a search engine stores almost all data it can find from different multiple websites, blogging, content, images, videos, all that. Same thing with large language models. They have taken all the content in text format and put this into this one model, which acts like a human brain. So when you think of a human brain, when I see a tree or you see an animal or you see a car, we get the input from our eyes like, okay, that's something. Looks like has 4 legs, tail. Then you decide, oh, it's a horse. Oh, it's a car. Oh, it's a tree. The way these same LLMs are designed the same way, that if these things they're matching, what is the next word? So that's how kind of it works. So the fundamentals of generative AI is there's an input, and that inputs is a prompt to these LLMs. LLMs understand, and then they generate output, and then output comes to you. For example, ChatGPT. You go to ChatGPT and you say, write me a code for sorting an array in C#. That's input. It goes to LLM. LLM looks for all the matching content, and then it generates output. That's your code. So how software architects can use generative AI to become more productive? In other words, save them a lot of time, right? That's all. Everything is about time. You save time, you save money. So I am going to break down this my talk in about 6 or 7 these topics. What based on what architects do. If you are a software architect or solution architect, what do you do? When you start a new project, I think first thing you start with is some kind of research and start creating some documentation, right? First, what you do is you meet, business comes to you, say business says, oh, we have a need of this new software, or we need to build a new solution for whatever problem. Business has a problem, they come to you. So first thing you do is you start doing a research, right? Research then turn to some kind of, you start asking questions, okay, what the goals, how many users, who's going to use it. And that's what, I've been an architect for many years. That's what I do. I sit down with client, get their requirements, and then almost turn them into, sometimes clients do have business requirements which are just general ideas, but then you have to turn those business requirements to full-fledged requirements documents, right? So generative AI, first thing it can do is, if you feed the data, you just tell ChatGPT or Claude or any of these tools, say, I'm trying to build this software, it's an application or it's a SaaS website or whatever it is, and these are the requirements, this is this problem, this is how I'm trying to solve. ChatGPT can go now and create you a full-fledged requirement. So that's one thing generative AI is helping me today, rather than me writing the whole document and spending, I used to spend weeks and weeks on that, writing requirements. Now it can do that for 10, 15 minutes. And then you can iterate through it. You can change it, you can add it, update it. But I think you will get almost 80% work done. So that's one thing you can do. Then it can also convert the requirement document to your either detailed functional requirements, or it can also convert into user stories, into tasks, break down into tasks that can then import it into your any of these project management systems like Jira. You can make Jira stories. You can even just say, oh, these are my requirements, can you create them into these, my Jira stories? It will go and create a Jira stories. Now you have to do just import them into your system. So that saves a lot of time, right? Otherwise, you have to have a scrum master or some kind of project manager who's going there and start breaking down into these stories. And I think in coming time, you will see that in Jira or these tools, you can import your requirements and they will automatically pass through and create these stories for you. You can also write test cases, right? So that's something you can think about. The second thing as an architect is what I need is usually is feasibility analysis. That's very important. And feasibility analysis means that when we build, business just came to me and say, we need this software. I have to ensure that can we do it technically? What does the time frame look like? When do we have to deliver the final or first product versus MVP versus first launch versus final product? What kind of resources and cost I need to allocate for this project? What are the operational and legal feasibility for that? Are there any issues for that? So all that, if you give this task to ChatGPT or any of these Gen AI models or app tools, they can go and measure your 80% of your work. So now think about me, I'm sitting a software architect, my 80% of work is done by this AI. Now I have a lot more time to do other things, such as understanding business requirements, look at other things. So that's one thing you can definitely start doing right away. Again, any questions you have, feel free to ask questions, and I'm going to take questions in the end. Now, biggest function a software architect does is in system design and architecture. That phase of SDLC, that's where they spend most of their time, is designing system, because some software systems can be complex, but these days they're getting a little bit better because there's so many tools out there. So now creating the system design documents is also a hectic work. I remember back in the day, I used to draw, these DFDs, diagrams in Visio. I don't know if any of you've driven those design documents. You have to have data flow diagrams, right? Now, in today's world, you can take the requirement that just generated by AI for you. You can take the same requirement, now plug in to AI tools and say, oh, can you look at this and build me these diagrams? You can ask for data flow diagrams. You can ask for entity framework diagrams. You can ask for models. You can ask for all those things, and AI can suggest you that. It may not all AIs can do everything, so you have to find the right tool, but you can always get this help where you'll have most of your work done there. You can look for evaluate different architectural patterns and trade-offs, like which patterns should I use, that what are the benefits of me using this versus that. So it can start recommending you automatically. If you don't know about some architects, they know what they're doing, what direction they want to go into, but sometimes there's always things changing, so AI can help you with that as well. How about implementing design best practices, right? You can just go tell AI that I want to make sure that we are following these best practices. Same thing with the security and compliance. And you can also say different scenarios, like, what is the cost, how it will impact load and failure scenario. So majority of your now architecture work done can be done with AI. I would say easily save you 50 to 60% of your time. The only thing here is that sometimes you may have to use different tools to do different functions, right? For example, if you want to draw a database diagram, right, the entity diagram, all that, ChatGPT may not be able to do that. You have to find a different tool for that. Now, the third part, so we covered first thing is the requirements and research and analysis, right? Feasibility analysis. Second part, we covered the system architecture and design. AI can help you in different ways. And we can take some examples in the end if I have time. The third thing is the tech stack, right? One of the decision software architects they make is that what tech stack are we going to use for this new system? Are we, for example, if you're building a SaaS website, which is going to serve millions of users, or at least that's what you're predicting, in 3 years, you're going to have at least 1 million users. What is the tech stack you're going to use? What is the front end are you going to use? What are the back end you're going to use? What kind of, are you using APIs, microservices? Are you a cloud native platform? What is your backend database look like? Are there multiple databases? Is there a caching strategy behind it? What is your authentication mechanism, right? All those things matter, right? When you decide that, while some of you decide that in the design, what components you will need in the design and architecture phase, and how these components will work together, how the data will flow from one component to other component, from back end to front end. The tech stack can still be decided here. And tech stack can be, right now, using AI, all you have to do is you take the requirements document or design documents and you plug into your AI or Chat GPT or any of those. They all do same thing with a little bit here and there. You just Chat GPT, you can plug in your document, requirements document or design documents, and say, hey, this is my new system. Can you suggest me a tech stack? In tech stack, you can clarify that my goals are these, that this is a SaaS website. It's going to also work on mobile. People will access there. We're going to have probably, first 3 months, we're going to have few thousand users, but end of the year one, we'll have 100,000 users. Year two, we'll have, 500,000 users. Year three, we have 2 million users. It should load within 3 seconds or 1 second, whatever. You can go as detailed as possible. You can go, and you can say, oh, it needs to be optimized for mobile screens or tablets and all that. And you can also say my team is expert or my team is experienced in JavaScript or React. Or you may say, oh, I'm not good in React, but we do Angular. So once you plug in all those things and upload your requirements, AI can now suggest you a tech stack. Not only it can suggest you tech stack, you can also say what are the other alternatives for me and what are the different drawbacks and benefits of using one over other. Now you have the big picture. Say, oh, I can use React, I can use Angular for front end, I can use Blazor for front end. A back end can be C# or Python or Java or whatever. Node.js, for example. Backend can be these different databases, right? You may say, then you can go back into more and saying, I don't want to pay a annual fees or licensing fee for my database. So can you suggest me an open source database that will run on a machine the less than 4 GB of RAM? It can now go and suggest you the database. So once you get these tech stack, you can also drill down into more depth and all the things you will ask, or you will go research, or you'll make some wrong decisions without AI. Now AI can help you with all that, right? You can also ask the stacks for based on key priorities. Priorities means sometimes you have to build a simple system just for POCs, right? Say all I need is quick POC. Can you find me a quick tech stack? It's going to give you a different option at that time. So, and then you can even get more details on these tech stacks, like what are the, let's say you don't have a team, for example, you're starting brand new. You can even say, if I select this tech stack, what is the learning curve for that? How much time do I need my my team to be trained on that, right? So now all those things, now you can make a decision on this, that, oh, this is the tech stack I'm going to use. Once you do that, out of sudden your life is simpler, because now you've made sure that you made the right decision, right? You can also give examples like, oh, I'm trying to build a website similar to Netflix. I'm not sure, I'm just giving you some ideas, right? I'm trying to build a website some similar to Netflix, where millions of people are going to stream live videos. And I have team, or I don't have a team, I'm going to hire a team. My goal is to build this in 3 months or 6 months, and my budget is this. You can put all those things, and based on that, AI will do its research and give you some suggestions, and then you make decisions from there. Getting all this work done in a fastest way possible and get this amazing output that you're expecting, the skill that is required is prompt engineering. So in the era of this AI, where everything is almost being developed, especially in software field, is developed by AI. Code is written by AI. It's being tested by AI. Software is written by AI. Documents written by AI. All majority of things are done by AI. One skill set you will need is prompt engineering. And prompt engineering is something, more you master, better you will get at getting this work done faster. And obviously, end of the day, it will cost you less. So next thing, so we talk about 3 things, right? First thing, you can use AI as an architect, software architect. You can use AI in research and development and feasibility analysis. You can use in system design and architecture. You can use to build and decide what tech stack you're going to use. And not only you can decide tech stack, now it can also obviously write code for you and build the entire software for you. That's already understood here. I'm not going to cover that in more detail, because architects don't really write code. Maybe they do a little bit coding. They may write initial framework, help with that, but that's already understood here. So I'm not saying that, oh, architects cannot use AI to write code. You can also write code. Say you're trying to show your team an API, a template or something, you can always use AI for writing those templates, right? I have a dedicated track on CSharpCorner just on Copilot, where it talks everything about what Copilot can do, from starting your project till the end, writing test cases, writing code, fixing problems, finding bugs, performance, and all that. So that part is already understood. What else architects can do? Take help from AI. Architects is also a big collaborator and leader. I'm not sure my whole slide is messed up here. So what does that mean? That means architects is the person who sits between, it's in the centerpiece between the businesses, the stakeholders, the developers, DevOps, and product manager. So everything, even users, also users, right? Architect is the glue there. And when these architects is the person sits there, there's a lot of things happen like sending emails, schedulings, asking questions, reply. AI can help you collaborate that as well. And there's several AI tools. For example, today you can go and build your own workflow using AI agent where it says, oh, if this is my project and this project, if I get this email from this person, can you do this? Remind me that. Take my work to-do list from Teams and respond to the management, or report, automatically generate a weekly report and send this to stakeholders. Or if their budget is over budget, this my team is over budget, so create a report and send it to this person. So those, beside the technical aspect, AI can also be used for that. And then last thing in this leader part is an architect is a leader. He or she is the person that's leading the entire team of building this new software. It's a product. So they mentor people, they mentor team people. Always they mentor their team. They also do some code reviews, look for quality, look for performance, all those things they look for architect, right? So now using AI, you can use Copilot, you can use all these Gen AI tools where you can do for code reviews, look at the designs, find the performance issues, mentor other engineers in the team. Also, sometimes you may have to write a documentation or a report or a paper or blog on some technology or teach somebody. You can use AI for help with all those things, if that makes sense. So end of the day, what I'm saying is that if you're an architect, you can save time at every step you do in your day-to-day job. Literally, you can use AI almost everywhere. So AI, you can think of that you have now an assistant sitting next to you all the time. AI doesn't take a break, doesn't need food, it just costs you much, maybe just a license. Now it can do work for you 24/7. It can also work while you're sleeping. So this is what AI can be really beneficial to architects, because architects are always behind the schedule. They don't have enough time. Now, if you learn and use this effective strategy and make AI your personal assistant, you can really move faster than you were moving before. Number fifth point is coding standards and governance. So using AI, you can enforce, as an architect, you can enforce these coding standards. So when you design template or design a project, you can schedule that every day before your code is checked and accepted. You can have AI review all the code for your coding standards, your architectural guidelines. You can make sure that code has consistent code formatting. It has comments the way you like it. You can also auto review and refactor legacy code. If there's old code coming up, you can maintain project naming conventions the way you like. You can maintain architectural decision records, ADRs. So all those things you can decide as an architect and enforce all those, and AI will do that automatically for you, rather than you really going in and spending your own time. AI can do that for you. So here is an example of prompt, right? You look at the prompt on the screen. If you go and type this in Copilot, and let's say Copilot has access to your current project, you can say, review this code and suggest improvements to align with the clean architecture, solid principles, and my team's TypeScript React standards, which you have already told in the beginning or filled it out somewhere, right? And highlight any violations you find and fix that. So imagine in today's AI world, when you are starting a new project, you can create your own standards, guidelines, formatting, naming conventions. You can just tell AI before you start, or you can have a document where you can write all these down and tell AI that, hey, before every time we check in the code and accept it and check in the code, please go read this document, guideline document, and understand that and review my code based on these guidelines. Now, out of sudden, your code is being done the way you want before it's checked in. And you can also say, if you find something, fix it automatically, and also send me the report. You can send me the report that which developer or which person in the team did that mistake, and you can do all kind of stuff. Whatever you can imagine, AI can do that for you. Okay, hopefully I'm making sense here, guys. Let's keep going. And then last thing I want to talk about is, as a software architect, what AI can help you with future proofing your software. And future proofing means when an architect designs a software, it's similar to an architect designing a new building, right? Imagine somebody's building a new tower in a city, right? There has to be an architect first. Architects, they know that when we are designing this tall building which has 60 floors, it's this space, what kind of base they need, what kind of material they're going to use in the building, what kind of glass they will use, what kind of angle they will use, all that is job of architects. Same thing with software. In designing a software, you have to think about, with the business, what is the life of this software? Is it a 5-year life? Is it 20 years, 10 year, or we don't know that? So when you design these systems and architect these systems, you should be able to predict that, I'm using JavaScript, I'm using React. So to run it for 5 years, we have to make sure, we have to have provisions that every year new version comes out, we can make sure that we can update this current version without too much work, right? You have to forecast these tech evolutions and trends, and also the growth, all these things. You also have to design the system. Is it modular, flexible, and adaptive? In the future, you want to add more to it, you want to change something, so you have to, same thing with the risk and long-term strategy, right? And also in future, what is the replacement or maintenance strategy? So you can use AI to when you are architecting a system, when you're writing a code, when you're deciding your tech stack, you can put all that and say, you know what, I'm trying to build a software, for example, that is backed by a company, solid company, and has a good community support, because if you have those things, this stack is going to last longer. Sometimes what happens is we pick these tech stacks, they don't last longer. It has happened many times. Sometimes you build these systems and using these new tech stack coming out, and 2 years later they're gone, there's no support. So AI can help us predict this, forecast these trends, that if this technology is by Google and supported by these millions of developers, it looks like there's a lot of big community support here, I think this tech stack is probably really good to pick, and is going to last for a while. So I hope you learned something today. So we covered, as a software architect, I wish I had more time to demo you and show you how you can use these different tools and implement, but since it's only 20-30 minutes. So today what we learned, as a software architect, generative AI, which is LLMs, you can use any kind of tools, ChatGPT, Gemini, Claude, whatever works for you, Copilot. Obviously, they all are useful, whichever is easily available to you, accessible to you, which one you like. I jump between multiple these tools. For certain things, I use Copilot. For something, I use ChatGPT. For something, I use Claude. I also go once in a while Gemini. So I do different things. You have to figure out which one works for you. So with that said, I hope you learned something that if you are a software architect, you should start thinking more, if you're not already, how you can use AI to benefit you, to give you a lot more time. You want to learn more about AI and trainings, just check out Learn AI at csharp.com or CSharpCorner. So CSharpCorner, this conference, the company and the website and the community that's bringing this conference to you, CSharpCorner. CSharpCorner, we are always about learning, sharing, and innovation. So you see a lot of AI learning there. If you have not visited, check out csharpcorner.com. And now let's maybe we'll take some questions if there are any questions from audience.
Perfect. That's a great session. I'm going to pull some questions that's coming up from the audience. The first one is actually by Hemant. He's asking for software architect just starting to integrate these tools, the one that you just shared in your session. What's the one tool of work you would recommend they try first for the biggest productivity boost?
So software architects are totally different because they all work in different companies and use different tools, right? So some people do just they like Word, some people do use diagrams and Visio, some used to do PowerPoints. Depends on what you do as an architect, what kind of some companies have already templates. You have to follow those templates for software architectural guidelines. So there's no one tool here. Obviously, ChatGPT and Copilot are big ones I would highly recommend for most of the work. It wasn't really a one tool to do all, it's more about how you use multiple tools to do different things.
Amazing. Well answered. Thank you so much for that, Hemant. There's another question coming from Rohit. He's asking, what are the biggest risks or pitfalls for architects who rely on GenAI for design decisions, especially regarding security or long-term maintainability?
Yeah, so Gen AI can fool itself sometimes. So there's something called hallucinations. It can hallucinate. So it can tell you the answers that are wrong and that are totally wrong. So architects have to make sure that think of Gen AI as an assistant which is junior to you. It's not senior to you. It can go and do a lot of the things. End of the day, you have to make the decision that is it the right decision or wrong decision. Gen AI can only do and give you the research and say, oh, this is because all Gen AI does is Gen AI doesn't have, even though LLMs are designed as human brain, they don't have intelligence. All they do is read from the old content and just from that and give you the suggestions. So, for example, a lot of the data Gen AI uses is old data, obsolete data. The design patterns could be older. If somebody created amazing design pattern recently, that may not be a part of Gen AI. Gen AI probably doesn't know it's there. So, for example, if brand new car just came out, Tesla just announced brand new car, and you ask Gen AI which is the best car, it will not know that. So that's where you have to be careful. So you cannot make decisions on something which is really cutting edge and latest.
Perfect. Thank you. One way to
Okay.
solve it is by grounding. Some of these LM these days have a small checkbox that allows them to access the internet. Sometimes, that's one way out. Do you have enough time to take another question, or shall we just move to the other session?
I think we're good. We're good. I think, yeah, but it was amazing here again. Love it. Looking forward to another one next year.
Perfect. Thank you so much for having me. I can definitely see there's some meetings written on your whiteboard, right? So, right, you have a lot of meetings there. So I'll let you carry on with the day, Mahesh. Thank you so much for accepting the invitation, and we'll see you next year,
All
maybe
right.
even
Thank you,
before that. We
Simon.
do a lot of
Appreciate
events.
it.
Thank you.
Appreciate it.
Bye-bye.
Thank you. Bye.
All right, ladies and gentlemen, that was AI for Architects by Mahesh Chand, and we have a lot of sessions coming up. I think we have 4 to 5 more sessions for today, and we still have about 5 minutes before we do the next session. So let's take a quick break, and I'll see you in a couple of minutes.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi everyone and welcome back. We now move to the next session of the Software Architecture Conference, and I must tell you that this is once again the recorded session before we move to the final session of the day that is actually live. Right, quite a few recorded sessions for the day one already, but I bet you in other days we don't have really a lot. So the next session is by Indranila. She's going to talk about architecting under pressure, balancing technical depth, deadlines, and business demands in B2B systems. It's a recorded session, so unfortunately we won't be able to take the questions, but I hope you enjoyed, and there you go.
Good day, everyone. My name is Indra Tsibikova. I have been working as a solution architect for almost 10 years. I had the opportunity to work on different transformation projects in telecommunication, cloud, distribution, covering very different scales, from projects limited to a single country and a single, but I would say major telecom operator, to global rollouts across multiple regions. Most of these projects have been in sector B2B, and yet, no matter what the industry or the scale, I often found myself facing the same rules of the game. So today, I'd like to share you my perspective, real-life experiences, and the practices that currently help me do my job effectively under different constraints, how to make architecture decisions. Here is the plan for today. First, we will talk about core challenges architects face in the real projects. Then I'll briefly remind you the specifics of the B2B business model and why architectural work so unique there. After that, we'll dive deeper into key problem areas: uncertainty, time pressure, technical depth, and business demands. And finally, to wrap up, I'll share a set of practices and lessons learned that personally help me deal with these challenges day to day. Let's begin. So, let's take a closer look at the reality of being an architect. Usually, when we hear the word architect, we imagine beautiful diagrams, elegant patterns, perfect logic, and the latest trendy technologies. But reality is quite different. In real life, an architect is not an artist. An architect is a negotiator and a strategist. In theory, we might have a luxury to do design of the system in a very perfect way. But in practice, we have product launch in 3 months, or we have to show demo in 2 weeks to a client, and at the same time, team doesn't have enough resources to help you here. And all of this needs to be considered right now in a way that will deliver the value without collapsing system tomorrow. Take a look at this circle. Sometimes there is some beauty, and we still try to make it beautiful, but in reality, 80% of our decisions are compromises. Even compromises can be beautiful, right? So compromises can be between teams, between what's possible, what is desirable, between speed and reliability. Sometimes they are conscious, sometimes they are forced, but most often they are simply necessary to move forward. And I don't think this is a bad thing, because in business, architecture is not about perfection. It's about resilience, manageability, and being adaptive to reality rather than fight against it, right? So if we accept that our work as architects in B2B is not about perfection, but about survival under constraints, the next question is, what kind of constraints do we really deal with most often? In B2B, we are constantly balancing on one side deadlines, on another resources. Sometimes we have to simplify the architecture and skip complex patterns. Sometimes we use technologies because they just simply work, and we can't replace them yet. So sometimes we require to postpone the tech debt, hoping to come back later if we ever do. So all of these constraints are not exceptions, and I think, and I'm really sure that They are normal reality for any business, and in your companies, it's more or less the same. And the important part here is to learn how to balance and work with them instead of always acting like firefighters. Right? So now let's move on. Let's take a minute to remind what is a B2B model, business model, and basically why it is a really category of its own. And let's compare it to the B2C. In B2C, products are built for a broad, often anonymous audience. So the focus is on scale, conversion, and speed. Decisions can often be adjusted on the fly. You can use feature toggles and launch today, redesign tomorrow, roll back the day after if it's really needed. Architecture in that world is built for mass adoption and frequent iterations. In B2B, it's like totally opposite. We work with a limited number of clients, but each of them is like a world of their own. We know their names, their systems, their requirements. And almost everyone wants the product for them, specifically customized for them. So we talk about high level of customization for B2B, special integrations that really can be deeply embedded into the core, and long life cycle. We do years of support. We have years of support, really, where stability, backward compatibility, and predictability are essential. On top of that, business and security demands in B2B are much more stricter. If in B2C, we talk about cookies and GDPR, in B2B, it's more about audits, SLA, compliance, sometimes even certifications, and everything directly impacts architecture. For example, you can't move to a new API version if a client is fully dependent on the old one. You can't just release the feature and fix it later if it affects contract and critical data. That's why when we talk about B2B, teams, the engineering teams, architecture, all the technical teams have to think not only about the system, so I would say everybody, not only technical. Everybody have to think about the client, their processes, and long-term consequences. So for the past 8 years, I've been working in this sector across telecommunications, cloud distribution. And so from here on, we will focus on the main constraints specific to B2B projects. And let's start with the most common one, it's uncertainty. So I think it's common when most everywhere in B2B, but to work without a complete picture of the project. And that would be fine, except these are exactly the conditions where we have to make architecture decisions. So imagine in front of us, we have a business stakeholder who doesn't have a clear product, but does have a mandate from the top. We have users we've never met. We face an existing system that kind of works, but it's slow. No one can really explain how. And on this slide, we're going to go through 3 key layers of uncertainty from my point of view that we face. The first, unclear requirements. Business wants something to be done. They want, but they don't really know what exactly. Business always comes to me and asking, we want to onboard new clients into our system. I say, okay, go, try. And when you figure out what doesn't work, please come at that time. Please make this gap visible for me. Sometimes they can say, oh, make this process like it was before, but less clunky. Make it faster, make it more convenient. What is convenient, right? No one can say. So, second, it's conflicting goals. Some people want speed, some people want stability, some want to spend less money. And in the end, you can end up in the 3, 5, 10 initiatives running at the same time, all competing for priorities and deadlines. So architecture in this context becomes the arena where these interests collide. So I have conflicting goals every planning round. We have 10 different projects, from different business stakeholders running at the same time. And yes, you have to prioritize, you have to start with something. So yeah, that's one of the challenge. And the third, lack of legacy knowledge. No documentation, experts unavailable. Systems works as long as you don't touch it. I have been working in the companies that are 30, 40, even more years old. So the landscape is really is something really, you know. So we have a lot of legacy, and it's really hard to find the expertise because people maybe they already retired, right? And all of these transformation projects I've worked on has been about moving from old to the new. And very often the migration is not a big bang, but a period of coexistence between two worlds, right? So it's also the challenge. So you need talent people to start working with legacy and make step by step, really slow steps in such conditions, because it's very easy to make a decision that will haunt you later. That's why architectural thinking here is not about elegant diagrams. It's about working with uncertainty, staying flexible, being adaptive, and gradually clarifying the context step by step. Now I'd like to share an example from my own practice, an experience I had about a year and a half ago. I was working on distribution on a B2B product, dealing with both clients and suppliers. Each of them has its own processes, integration formats, and data. In an ideal world, we would have a universal engine where everything works by the same scheme. But in B2B, that simply doesn't exist. Everything is client-specific. Especially in the legacy systems, we often find the business logic hard-coded for a particular client, no documentation, knowledge only at the heads of few experts, or even sometimes in the heads of the business stakeholders who has been working with the client or supplier for 5-10 years already. And they know all the nuances. At the same time, your client can change their requirements, and then we have to adapt quickly, really quickly. Otherwise, we're going to have some losses. And what can we do in such situation, right? What do we do? Instead of hard coding every client scenario, we introduced an abstraction layer implemented through a low-code, no-code solution. The idea was simple. Universal engine for everyone is not possible, and it will be very costly, and it will be slow. Instead of developers coding for each client and repeating the same what we had in legacy, we gave business a tool to configure rules and user flows themselves. Business owner became the expert of their own configuration without pulling the developers for every change. So we gain flexibility, we gain speed to adjust, and it became scalable. So that's one of the options how to deal with uncertainty, not to try to eliminate it, but to adapt to it, make the solution adaptive, especially when the change is not some exception, but it's a constant. And moving forward, we may have clarity. We may have even alignment. But there is always one factor that rewrites the rules of the game. It's time. And time always pushes us to move quickly, to start running in circles, right? And that's when things get interesting. Priorities start to shift. Architectural tasks pushed aside. Technical depth get ignored. In this situation, teams start running, delivering solutions simply so that it works. Sometimes that's a reasonable compromise. For example, it's just for MVP, it is one-off, and we can skip a target solution or create a temporary one, or we have a client demo. But here is the thing, not every compromise is the same. There are conscious, temporary ones documented with the plan for improvement. And there are those that make into production and stay there forever because the team rushed off to something next and forgot to come back and clean it up. And if it's not documented, there is no one and no reason, no understanding to fix it later. What was meant temporary becomes technical debt with interest. And as you see on the slide, one day the debt can erupt like a volcano. So our job is not to slow down the business. In the end, it's business, right, who brings value and revenue. We have to help them. So it's very essential that if we simplify something, if we create something temporary solution, if we create the technical debt, clearly call it out. Write it down and write it how it can be fixed, and most important, when. I had, of course, experiences of such cases where technical debt that was kind of lost. I would say it was lost because of the time pressure, because of the business demands, and it was kind of found by myself when I did architecture audit. And I found that in one of my systems, there is one functionality that shouldn't be here. It just, from the capability map standpoint, it shouldn't be there, but it's already there, and the solution is rolled out. It works, but it creates problems for performance and load. And now this is my technical debt, and this is my responsibility to solve. But it's kind of scary. So for that, I need to work on the plan. So what is our technical debt, right? Not all technical debt is the same. On the left, we have conscious debt, decisions we make for the sake of speed with risks clearly understood. We understand the risk when we make this decision. And this is not the bad thing. It's our tool to move forward, to help business, but we need to address it. We need to document it, as I said, I think, multiple times. And most important, we have to plan how to address it and when. On the right side, we have unconscious debt caused by inexperience, haste, or simply lack of context. This one is so dangerous because it often goes unnoticed until it causes serious problems. As architects, our role is not to avoid debt totally. That's impossible. But ensure that it's conscious, visible, and manageable. As soon as we have this visibility, we can work on the risk management even. So next question, what do we actually do with it, with this debt? Because identifying the debt is just the beginning. Managing technical debt is not about fixing everything at once. It's about building a process. First, we define the debt, identify the areas that slow us down, where we have problems. Then we track it with metrics, so we know the impact. Also, metrics can help you to kind of sell this technical debt, so it could be added in the roadmap. So sometimes it's really good from the practice standpoint to track this, to connect the debt and the business impact together through the metrics. So you can always have an argument to talk when you work on the roadmap. Then the third, we plan the repayment, making sure it is scheduled and not left for someday. And finally, we architect solutions that solve the root cause, not just symptoms. And here's where you need to spend a lot of time, I would say, and find the root cause. Sometimes root cause is not, sometimes not even in this domain. Sometimes it can be business process change. Sometimes it can be just misalignment. So this cycle is what keeps technical debt under control instead of letting it control us. And yes, of course, it all sounds simple in theory. Just manage your technical debt. But let me ask you, what percentage of tasks in your roadmap actually relates to paying off technical debt? In practice, it's extremely difficult because there are always more important priorities coming from the business. Sometimes you even have to prove to everyone, your business stakeholders, your engineers, your product team, that what has already been built is not scalable enough or doesn't move us forward to our strategic goals. So honestly, for me, it's a constant struggle, pushing hard to schedule debt repayment and then actually making it happen. That's why architects must also be good negotiators and communicators. And yes, there are going to be conflicts, but they have to be good conflicts. And we need to find a way to make the case to show why reducing the debt is essential for long-term success. And I just mentioned that business always seems to have more urgent priorities. So let's talk about that pressure. Because as much as we care about architecture, we all know that in the end, it's the business demands that drive the pace, deadlines, and often compromises we have to make. When we talk about architecture under pressure, there's often an unspoken undertone. The business is in the way. They forced us. They just want it fast and cheap again. And to be fair, sometimes on the business side, you'll hear the opposite. All those architects, they block us. They doesn't let us. They slow down the things. But the truth is, business is not the enemy. The business has its own mission to move the product forward, to deliver on goals, revenue, and customer needs. And our mission is to make sure that this movement doesn't break the system, that the product will stay alive and resilient. As you can see here, on the one side, we have the strategic goals and the processes of the business. On the other side, we have technologies, trends, and architecture. And right in the center, this is the point where the two meet and the space where informed, innovative, and sustainable solutions can actually emerge. That's why partnership with both business teams and engineering isn't just helpful, it's essential. And when I say partnership with business, it's not about saying yes or no. We help business see which features can be launched quickly, which will require deeper technical changes, and where the risks are that may not be visible in the business plan. So sometimes the right solution simply can't be implemented. While the team is still following outdated patterns or while the business is doing 5 manual steps that could easily be automated. And this is where the architect steps in and show and say, if we adjust this process a little, we can speed things up or simplify the support, or we can save some money. In this way, architecture directly shapes the business roadmap. We can suggest phased approach, we can highlight hidden risk, and I think this is how trust is built. And when the business comes not to demand a feature, but they come with problems, and then you can find together the best way how to solve this problem or how to go towards our strategy in future. That's why partnership is not just important. I think this is the basis for sustainable growth of the product. And before going and sharing with you my key principles, how to do these architecture decisions, I want to go through the case from my experience that I think went through all these stages. 2 years ago, I joined a project that was both critical and urgent. While analyzing the solution landscape, I noticed and discussed with my fellow architects a serious issue in our legacy system. Because of the issue, we simply could not launch sales of the new products globally without touching multiple legacy systems, different in each region. So the idea emerged. First step. Extract logic from legacy and move it into the new engine. And we were already in the process of moving from the legacy to the new one, so that was just another part of the business. So the secondly was to add this item into architectural roadmap, so I can work on it. So I started with domain analysis, business processes review, and exploration of possible solutions for each region. I tried to find the common process. Once idea was shaped, I had to go to the business and essentially sell this project. That part alone took 5 months. Yes, because I simply was working on this in parallel with my daily other projects that are running. And that was just my idea that I need to kind of move it forward. So for the next year and a half, I think for the next year, I worked to promote this concept across regions. And finally, this year, I got the agreement and business was ready to allocate a budget for implementation. So as soon as we had the budget and priorities, we could form the team, product, engineering, everyone, and we started the detailed analysis. And at the same time, we got the mandate from the top. We need the system live in 3 countries within next quarter. Okay, I designed the MVP. We've developed architecture for the target solution, global solution that will be generic for each region. But in one country, there was specific dependency that required additional architecture, integration, sorry. And that was a dependency with another team's roadmap. This meant we had to design and additionally, we had to do we had to move away, kind of move out from the target architecture and do this interim solution. So I discussed with the business the option of starting MVP even in another country to avoid that. We weighed at all the pros and cons. We put all the options on the page. But in the end, it was clear we couldn't move forward with another country and we have to go with this technical debt. So we documented it clearly in the design document using architectural decision records. And we planned it when it will be removed. Also, I highlighted the dependency on another team. So architect from that area could help me, and we can work together on that. And now, basically, I'm working on this next phase. I'm removing this technical debt together with my colleague, and we align this with the target architecture. Yes. There were also some situations when I had to say stop or no. For example, while building the functional map of the new engine, I had to step in and explain why certain functionality didn't belong in the system. In the end, I'd say we built strong partnership with business within the team, and I hope we're going to solve major business problem together. This case I just shared went through all of these stages in one way or another. Everything we talked about today, compromises, deadlines, uncertainty, leads us to the real question: how do we make decisions under such conditions? The answer lies in flexibility and strategy. So let me highlight a few key principles. First, acknowledge reality. There is no ideal solution. There is no ideal textbook. Architecture is about managed adaptation in real-world conditions. Second, follow the principle of living architecture. Make architecture flexible where change is likely. Introduce abstraction layers, right, where is uncertainty or volatility. Isolate temporary models. Track technical debt in code documentation, or maybe Jira if it's more common. Third, document your decisions. Use some framework. For example, use architecture decision records. Capture all the compromises. Why do you do that? Why do you accept it? When you're going to change it? And what was the conscious trade-off? Fourth, negotiate. Be a partner, not a referee. Don't just say this can be done. Explain it in business terms. If we do this, here are the risks and costs or consequences. Help the business build a roadmap through architecture. Let's start simple and then scale. Put architectural goals on the roadmap. This is 5. Don't wait until someone asks about the technical debt or something like that. Be proactive. And 6, still know when to say no, when to say stop. Some compromises destroy the system. In such cases, you must say no and propose an alternative solution, even if it takes longer or will cost more. These principles don't make decisions easy, but they make them honest, explainable, and resilient. And I think that is what real architecture is about, not perfection, but the ability to design within different limitations. And to finalize today's session, I want to leave you with the key things that compromises are not a weakness. They are part of our profession. The important part is knowing exactly what trade-off you are making. In B2B, flexibility and adaptability are essential. There is no such thing as universal solution. Architecture is a means, not an end. It exists to serve the product and the team, not the other way around. We not build architecture for its being. We do it to solve certain problem. Informed decisions are far more valuable than perfect diagrams because we are the ones who will live with them later. And finally, architect is a partner, not a theorist, not the barrier, but the one who can connect strategy and execution. My main message is this: in reality, perfect conditions never exist, even in regular life, right? But what we can rely on is careful, systematic thinking, good communication, and the ability to keep direction, even if the path has to change. Thank you for your attention. Hope that was helpful for you.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
All right, everyone, welcome back to the Software Architecture Conference. We are now moving towards the final session of the day, and the speaker is already there behind the scenes. Ray, I say him, I think I'm going to bring him 5 minutes early. So never mind, we'll give him more time. He can have 40, 15 minutes, all the time he needs. But it is the final session of the day, and it is a very interesting session, building secure APIs. I think this session is for everybody, for someone who even has 10 years old of working experience, or someone, who's just building, who's just learning to make the very first API request, right? I think this session is super important. And to talk about this super important session, we have Sri Varma Vegi Raju, and I always mess it up. I'm hosting this gentleman for the second time. I remember last time, if I'm not wrong, he talked about the observability, right? And it was very well received. So without any further ado, let's bring the gentleman in. Hi, Sri Varma, how are you?
Hello, Simon. How are you? I'm doing
I'm
good.
sorry, I'm already messing up with your name, right? So
No,
I
it's
apologize
completely
for
fine.
that. You must be habitual of it, right?
Yeah. And also the iPhone triggering when somebody calls me Siri. So got used to it.
I didn't see that coming, and I'm so
Well,
Okay,
it's good to be back here. I mean,
Yeah.
I love Software Architecture Live, and it's great to be
Yeah.
back here. And thank you, Simon, for hosting this.
Yeah, thanks for for taking all your time. I know it's a work day. You must be very busy, right? So we just can't wait for your session 3. Whenever you feel like, please feel free to go
Let
ahead and share your
me.
screen.
Yes.
And you're in the East Coast, or you're in the West Coast, right?
Yeah, I'm in the West Coast. One
Perfect.
second. Presentation.
How's life in US these days?
It's pretty good. I mean, it's going on, pretty busy, and it's business usual. That is what I would say.
All right.
So
Okay,
give me 1 minute. Are you
Okay.
able to
I think if you
see
go in
my
the
slides?
presentation mode, I see your slides, right? So I think you need to go into the presentation mode so that we can see your full slide, or you want to run it this way.
Oh, wait. 1 minute. Stop sharing. So what do you see now?
You stop sharing, Siri, so we don't. Do you see anything? I know these meeting tools, this can be sometimes really funny.
Yeah. 1 second. So let me go back here and share screen. Okay, can you give me 1 minute?
Don't curse, Siri, don't curse, don't curse.
So, okay, I think now it should be, okay, presentation. Okay, let's see. Okay, what do you see now?
I see your slides on full screen. That's perfect. Right? Everybody else can see your slides, and next 35, 45, 55, all the minutes is all yours.
Awesome. Thanks a lot. Yep. Okay, I'll get started. Hello. It's good to be back on the Software Architecture Live. Last year, I did a session on open telemetry. Please feel free to watch it. And this year, I'll be doing it on building secure APIs. How many of us have interacted with APIs? Actually, let me ask a different question. How many have not, right? We interact with them on a daily basis. When you are either streaming or you're buying anything on the e-commerce store, or even chatting, or even buying something. So you are using APIs daily. And they are very important, and they have become essential part of our lives, majorly for developers. And today, in the world of vibe coding and using Gen AI, the number of APIs that are coming up has grown exponentially. So every minute or two, you can spin up an API, which is pretty quick, and you can set up a demo. While this is very good, something that needs to be kept in mind is the APIs that we build should be secure. Otherwise, it'll end up in the form of breaches that will cost millions of dollars for your company, and not only cost, but also it'll damage the reputation of the organization and maybe even lose customers. We'll see examples of that. So as part of the session, what we plan to do is understand how we can build these secure APIs so that our organizations and our data that we host for our customers is robust and secure, and customers can trust us. Before we deep dive, a little bit about myself. My name is Varma. I am a senior software engineer with Microsoft, and previously I worked with Oracle. In my free time, I love to contribute to open source. I'm an active contributor to the Dapper CNCF project, which is an open source initiative. Please look at that. This is my LinkedIn and email, and please feel free to reach out to me if you have any questions or suggestions regarding the talk, or if you want to talk about software engineering in general. Coming to the agenda, we'll first look at what are the different authorization and authentication schemes, and basically from a security standpoint, what we need to emphasize on. What are the loopholes in authorization authentication if that would happen if not configured correctly, and what are the mitigation steps we can take. Similarly, we will look for server-side request forgery, security misconfigurations, improper asset management, and the need for proper security logging and monitoring. For each of these, we'll understand what the problem is, the problem for not configuring them correctly, what are the mitigation strategies, and in some cases, we'll also look at some code examples because that is what developers love. So first, let's start with authorization. So broken object level authorization. What does it mean? Okay, imagine the scenario. You are on an e-commerce website and you have a profile. Similarly, tens of other users on the e-commerce website have profiles. I, as a user, should only be able to see my profile and not somebody else. If I'm able to see that, that is what is called as broken object level authorization. For every entity, in case of e-commerce, for the user entity, for the product entity, everybody should be able to see resources that only belong to them and not somebody else. For the vulnerability via object ID manipulation, anytime if you have done a get on a URL and the get use, for example, let's say I do get user Siri Varma with a specific ID 123. Now, if I'm able to change the URL ID to 456, if I'm able to get the details of that user, that is a problem. So this is what broken object level authorization means. And the real world attack that happened is on T-Mobile. It was a data breach in 2018 or 2019, I think, when attackers were able to store, or when the attackers were able to store the customer information, which includes zip codes, phone numbers, and addresses. So what they essentially could do is open other phone numbers or other accounts using these details, which is a major problem for the users. Let me show you a code example as well. So on the left, what you see is a vulnerable code, and on the right, what you see is the code which has the vulnerability fixed. So here we are trying to get the profile of a user with ID 123, right? So if I'm not able to find the user, of course, I return a not found. But if I am returning it, if I found it, I'm returning that. Now I'm returning this to anyone, right? That is the problem. So now if I change that ID to 456, which does not belong to me, I'm returning that user back, which is not good. On the right side, what you see is here, I think these code snippets are kind of same. Sorry, I think I forgot to add the authorization check here, which is my bad. But what ends up happening on the right side is you would check for if the user ID here belongs to the user ID that has logged in. If it is not, then you would basically return saying not authorized. I would actually go and take a step further. If you don't find that user, return not found completely, right? So that you don't tell the user that a particular user with an ID already exists. So essentially what I'm saying is, instead of just checking if the user already exists, you should also make sure the person who has logged in is what we are fetching the information about. Coming to the mitigation strategies. So as I was emphasizing before, there should be a mandatory check which states about if the logged in user and the details of which we are retrieving the information belong to him. If not, then we should just send an unauthorized. This is where the permission validations also come into picture. So this is about authorization. Fundamentally, what we want to answer as part of authorization is, am I able to perform this action? And I should be able to perform this action only if the data belongs to me. Next, what we have is broken user authentication. Authentication and authorization are two critical pieces for any identity infrastructure. Authentication is what tells you who the user belongs. Is he a valid user? That is the one that authentication states. And what the authorization states is, okay, you're a valid user, but do you have access to this particular resource? Now, coming to authentication weaknesses, allowing users to input weak passwords, for example, 1234, or putting the username as password itself. So we as developers need to make sure there are certain policies in place which would guide users to put in stronger passwords. Next, lack of multi-factor authentication. If you ever try to change your credit card information on Amazon, it asks you a password the second time, which is nothing but multi-factor authentication, right? So not only when you're purchasing something, but when you're changing critical information like passwords or payment information, it is important that we perform a multi-factor authentication so that we know the person who is actually logged in is the one doing it. That is very important. And without those strategies, you might risk compromising. Another thing is, normally in 90% of the scenarios, OAuth is what we use for OAuth is majorly used for authentication, and JWTs, JSON Web Tokens, is what we use for authentication. How many of us validate the correct audience? So JWT has an audience claim, which makes sure if this particular audience may be a web application, is the right one calling your API. Without that validation, there might be a compromise as well, right? Not only that, we should also make sure we validate the expiry. If the token has expired, we should make sure the token is refreshed. Otherwise, we don't let the user log in or perform any kind of actions. So these are very important. So on the left, what you see is I am decoding a JSON web token, and I'm just using the JSON web token to get the user by ID. Here, I'm not performing any validation. But on the right, if you see, I'm saying if the decoded token has expired, return a 401. Similarly, there should be other checks as well. For example, using strong algorithms. Whenever we are signing the JWT token, we should make sure that the algorithm that is used to sign is stronger. Otherwise, people will be able to brute force the token, and then basically do a request for force the tokens and use them for authentication, which is very bad. So that is why use stronger algorithms, validate the audience claim, and decode and check for expiry. In addition to that, we should also make sure, as discussed previously, there is multi-factor authentication involved, strong password policies, make sure the password policies have numbers, numbers, characters, underscores, or anything of that sort, and enforce them on the user, right? And also make sure you monitor any kind of anomalies that are happening during authentication. For example, if you are seeing a spike in the number of authentications that are happening, that might be an anomaly. Maybe somebody is trying to brute force something like credential stuffing, where the attacker tries different passwords to brute force and break into your system. Identify those anomalies and take preventive actions to mitigate the issue. Next, what we'll talk about is broken object property level authorization. What this essentially means is, let's take the e-commerce scenario as well. In the e-commerce scenario, I have a product and I fetch the product, but when I'm submitting it, if I am able to modify the number of products, for example, if the product has a count of 10, that means there are 10 available products of the same thing. And if I'm able, basically the quantity, if I am able to change the quantity, then that will have serious repercussions, because I, as a user, because I don't own the product, I should never be able to change the quantity. Similarly, if you ever browse Netflix has modes for children, for adults and stuff, right? If I am able to modify any of the parameters, for example, let's say this particular content is blocked for children, but if in the API I'm able to modify that content, the block to true, that is a problem. That is when you have a object level authorization problem. Meaning, in a particular object, if you're able to modify the properties to which you shouldn't actually have access to, That is what is called broken object level property authorization. So in the case here, I have a user and have provided the update endpoint. Normally, what should end up happening is I should be able to update my email, right? If you see here, I have the user object, which has ID and email. Here in the vulnerable code, I'm just getting the user data and saving it directly. So what has ended up happening is if the user somehow modifies the ID to 456, I'm even saving that. But should the user actually be able to modify the particular ID field? No, because that is something internal to our system and the user shouldn't have access to that. So the way to mitigate that would be you should only get the fields that are required for you to perform this particular action. For example, in this case, because the user can update their email only, we will get the email property from the payload and then just create an object out of it and then only save the object. So in this way, you are not allowing any fields to be updated. And more importantly, you're not allowing the fields that the user does not have access to be updated. So this is where some of the mitigation actions that we as developers can take is, some of the mitigation actions that we as developers can take is validating what properties are coming in, exposing the properties that the user only has access to, just expose them, and while saving it, just make sure we get the required fields that is necessary to perform this job, and then just do that. So this is where what I was talking about, avoid direct binding of user inputs to internal objects, get the required fields only, and then validate all incoming data rigorously before processing or saving. These both go hand in hand. The fourth one we'll be talking about is lack of resource and rate limiting. When you expose an API to the outside world, there are a number of people that will be accessing it. And there are some situations in which you'll be getting a burst traffic. For example, let's say if you're using an e-commerce website and you have these days when you have a discount spree, right? In that case, you expect traffic. But what an attacker can also do is he can bombard the API so much so that your API will go down, causing regression to your actual customers. So the attacker was able to successfully overwhelm your API with millions of requests that your server couldn't handle, and it'll offer a degraded experience to the actual customers. So that is what resource and rate limiting vulnerabilities mean. This is where rate limiting is also important. What I mean by rate limiting is if you use a third-party service like an API gateway or an Azure front door or any of the other API protection services, what they are able to do is they are able to thwart this requests away. They offer a protection so that your API is not overwhelmed. Another problem with the resource exhaustion is, let's say you're using any of the cloud providers and you don't have proper limitations set up on how much scaling can happen. For example, let's say you have an EC2 instance and you have 3 or 4 EC2 instances currently. An attacker bombards your API. The number of EC2 instances you don't have an upper bound limit on, so they go to 100, right? Now, at the end of the day, you will get a big bill because there is no upper bound limit you have put, and somebody was able to bombard your API so much that you might be having a $10,000 or $20,000 bill because of the 100x instances you're running, it might spike to $200,000 or $300,000, right? So you have not only impacted your actual customers, you have also got a big bill, and which is not from a valid scenario, right? So this is the main problem of not having proper resource limitation and rate limiting guardrails on your API. And the way to protect yourself from doing this is, as I was stating previously, use something like API gateways. API gateways can also do authentication and authorization, but the major advantage you get is throttling, right? You could throttle based on requests, based on payloads or whatever, but you're able to limit the damage that is done to your service. Next, put upper bounds to your scaling. For example, make sure you don't scale more than 10x of whatever your instance count has. Make sure there are upper bound limits on that. Of course, when there are valid scenarios, you can increase these limits whenever you want, but make sure there are upper limits on this. And as usual, continuous monitoring and making sure any anomalies are identified. The broken function level authorization, what this talks about is, we as API developers have internal APIs, public facing APIs. And let's say you have an internal facing API that only an admin needs to have access to. If I don't have proper authorization attributes set up, and if a non-admin can access this, that is broken function level authorization. For instance, let's say you have different roles and your API is responsible for assigning roles to different users. Only the admin should be able to do this and not anybody else. So without that limitation, what we are basically saying is the function level authorization is not done properly. That means if anybody other than admin was able to perform the action of role assignment, then you have a function level authorization issue. Remember, we talked about broken object level authorization. Just to mention out the differences, the broken object level authorization talks about if I, as a user, can access only what I was supposed to have access to. But what function level authorization talks about is, for this functionality, only this role should have access and nobody else. If somebody without that role has access, then that is when you have broken function level authorization. So on the left, what you see is what I, as an e-commerce website, want to make sure is nobody except the developers should be able to delete a user. But on the left, I am offering a delete API, which is fine, but I'm just deleting the user directly. I'm not checking for anything else. Now, how I fix that is, on the right side, I'm checking for if the user role that has logged in is an admin or not. Now, if it is not an admin, I'm just going to straightly say forbidden, right? I'm not going to allow them to do any operation. And the second important thing to keep in mind is the current user should always come in from your authentication context. That means for the current user, there is an authentication context you maintain, right? The current user should always come in from whoever logged in. That is what the current user stays. And the current user would have a role, and that is what we should always check against. And once that is good to go, then we can go ahead and delete the user. So as we were discussing mitigation, role-based access control. This is very important. Your JWT token or your authentication, whatever way you're doing, each user should assign a role and every API should validate against that role. And always restrict privileged operations. What I mean by that is, for example, if you're allowing your developers to delete some users, make sure they cannot do it in bulk and make sure they cannot delete 10 or 15 users consequently, right? Because that is an anomaly, and once you delete something, it is very hard to restore it back. So what I would recommend is for any business critical operations, right? For any business critical operations, like where you have to update a product or perform any privilege operation like role assignment, deleting cloud instances or anything of that sort, maybe make sure nobody can do it more than 2 or 3 times in an hour, just so that you have proper safeguards and the users are also protected from any kind of anomalies. Next, what we have is security misconfiguration. Security misconfiguration can come in many forms. The most common example that we'll see is, for example, you have a storage account, right? With storage account, you can have 2 things: allow public access, don't allow public access. Most of us would first start with allowing public access, and most of us would start with allowing public access, and then it would be hard to move to it would be hard to disable that. That means once the public access is enabled, the bucket becomes available to the entire internet, right? And one small error, for example, let's say you are not doing any proper authentication or authorization on that, that's it. All the objects in your bucket are exposed to outside users. So that is why what we as developers or users need to make sure of is, does this bucket really need to have public access? Think about that. If not, just disable that. That is one example of misconfiguration. Another example of misconfiguration can be not configuring your TLS security or using HTTP instead of HTTPS. HTTPS is the default norm now. And if anybody is still using HTTP, which is unencrypted traffic, then that is a no, because a man in the middle can intercept all the traffic and listen to whatever is happening, right? So this is where I would recommend starting with hardening or configuration. One more example that I can provide is, for example, if you're using cloud resources, you would form a networking boundary, and any access outside of the network boundary should go through a firewall, right? So that is one thing that would come into my mind, so that I don't have my resources exposed to the public internet. Next, secure default. Start by disallowing public access first, and then, if needed, start with minimal and then expand your scope. Because once you start with a broader scope, going to the minimal will become hard. But if you start with the minimum one, so the broader scope can be public access, the narrower scope can be only allowing your firewall to access it, or only allowing some resources within your VNet to access it, right? So start always with the narrower scope, and then broaden your scope as required. That is one more thing I would keep in mind for security configurations. And always keep monitoring these security configurations and codify them. What I mean by that is infrastructure as code. The benefit you get with infrastructure as code is you have multiple reviewers reviewing your templates. And when there are multiple reviewers in picture, they are able to identify if this can cause a security incident, right? So that is where infrastructure as code also comes into picture. And with that, by using those constructs, you are able to provide a better security perimeter for your services and eventually for your customers as well. Injection attacks. This is the most common, and this is the most common scenarios we have heard of. And one very common example that comes into injection attacks is passing the parameters that come from your API directly to your SQL script. So one example is, let's say you have the user search something, and you have a SQL store backing, where you do a select star, and that would give all the products, right? Now, what if an attacker just puts a script something like 1 = 1, which is true, right? Which is true for all scenarios. So that would mean they would get all the data of all the users or all the products, which is nothing but injection attacks. And even till date, even when we know that injection vulnerability is the most common one and we have to be secure against it, we still have the issue till date, right? So that is why always parameterize your input parameters. So what I mean by parameterizing is, for example, let's say when somebody sends you an input request, you have two different types of parameters: path parameters and query parameters. If you just make sure they don't have any SQL, make sure they don't have any anomaly characters in it. For example, if you're going to select for a product name would generally have just characters and digits maybe. So make sure the input always only has that and no other malicious characters like equal to, $signs, and then so on. Next, don't directly pass in the parameters that you have from the API to the SQL object, to the SQL database. This is where, if you have heard of, there are data transfer objects which do a bunch of validation and use that validation and then only pass the parameters to your SQL database. And today there are a ton of SDKs that only pass in parameterized query parameters. So they are already offering you that security. You don't have to build something from scratch. So this is about injection attacks. Server-side request forgery. SSRF attacks come into picture when you have webhooks. So what ends up happening is, let's say I have a GitHub webhook, which I configure to make a remote request to a certain URL, right? Now, if an attacker configures the URL to be a localhost URL, now when you are providing that gethook parameters, the localhost would majorly mean something that is running on your server, right? So they will be able, so attackers could identify what all services are running on your server by using this attack. So basically what ended up happening is the webhook took a URL, which in this case was a local host. And when the webhook called the localhost URL, it was able to identify what all services were running on the localhost and send it to the attacker. This is where server-side request forgery comes into picture. And the most famous attack for this is the AWS metadata service vulnerability. So what ends up happening is, I think this was before 2021 or 2020, each EC2 instance offers IMDS, Instance Metadata Service, that exposes the instance details along with the SSH keys. So what ended up happening was when somebody was providing these web hosts, the attacker put in a localhost URL and was able to call in the localhost metadata service because that runs on a specific port. They were able to call the metadata service, get all the keys running, or get all the public and private keys and send that to the attacker itself, which basically resulted in a major compromise for a bank, right? Of course, after that, authentications were added to IMDS, but this is what we have to keep something in mind. And the way to mitigate the SSRF attacks would be, one strategy is to maintain whitelist and blacklist URLs. For example, if the URL that's in a webhook is localhost, and that check that against the blacklist. And if it is blacklisted, don't call that. Just tell that. Just send the response back to the user saying this is a blacklisted URL. Please use a different endpoint. And with the blacklisting, and also one more thing is network segmentation. How this will help is you want to provide a boundary for your service so that even if there's a compromise, only your network boundary is compromised, and the other services which are hosted in other network boundaries are pretty safe. So that is where network segmentation also comes into picture. So to summarize, there are two main things I would use. First one is blacklisting, and I would always check the URL that I'm calling is not against this blacklist. That is one. And second one is network segmentation. Unrestricted access to business workflows. So this comes into picture when you have one example that I can think of is, let's say you are Adidas and you're selling sneakers, right? You're selling Yeezys, and generally they are in pretty high demand, right? Now what ends up happening is, let's say Adidas say, hey, on August 15th or 16th, I'm going to put up these shoes for sale. An attacker or somebody can write up a bot that would look for when this product is going live and buying all the products, right? Now, you might be thinking, well, all the products are bought, so what is the problem here? Adidas has got good sales. But the problem is, if only one user was able to buy all that, that means your actual users in this case. So what this user might be doing is buying all that and selling it in a black market, right? Selling it for higher costs. Now all your other users are dissatisfied. And if it happens more than twice or thrice, then customers will actually lose trust on your system because they will never be able to buy these things. That is why if you see, there are always restrictions on how many products a user buys. So for example, if in this case Adidas would just say, hey, if I would let only logged in users buy, and if you're logged in, I would not let you buy more than 3 shoes, right? So that is how you would restrict access to business flows so that most of your customers remain satisfied, and you protect yourself majorly against bots. So, and then improper asset management. With improper asset management, what comes into picture is, for example, as I was talking about vibe coding and a bunch of APIs coming out, there is something called API proliferation. What I mean by that is, you just keep on spinning APIs left and right, and basically your organization has lost how many APIs does it have. And normally, these APIs have access to databases, right, and user data. And when you are not actively maintaining something, or you actually even did not know an API exists, that is what would those are vulnerable to attackers, right? They will use that API and identify vulnerability, and with that vulnerability, they will pull in all the data. That is why always make sure you have a inventory of all the APIs that you have, and make sure if you're creating any public facing API, that goes through a proper review board where you have a bunch of architects reviewing your APIs, and they are protected again, they are regularly patched, right? That is one thing to make sure. First, inventory all the things you have, and second, make sure spinning up APIs, you only spin up APIs if there is an actual business requirement and any of the existing APIs don't serve your need. So the best practices for proper asset management would be, as I was saying before, maybe you have an API gateway which maintains all the inventory of this, where you have exposed to all the APIs, and also regularly on a quarter to quarter cadence or even more earlier, deprecate unused endpoints. So when you start regularly auditing what is happening, you will be able to draw a picture of what all inventories, what all APIs are available, and what all APIs have access to your databases. Check if these APIs really should exist and can be deprecated, and start the deprecation process. Insufficient logging and monitoring. With all the strategies we have discussed previously, still there is a risk of APIs compromising, right? That is why, as I was stating previously, you need a proper logging and monitoring scenarios always available. That means your monitoring should let you know and identify any patterns that are anomalous in nature. For example, let's say you see a constant rate of 1,000 requests per minute, but suddenly on one day you see there are 10,000 requests coming in. You should have proper visibility into what are causing those requests and are they actually valid requests. For that, set up these monitoring, and not only monitoring, but also proper alarms on them. For example, in today's world, there are a ton of machine learning algorithms and Gen AI algorithms that look at different data and are able to identify anomalies, right? Make sure these are triggered and make sure they are set up so that they can trigger and let you know that, hey, there is something anomalous going on. The second one is, without these, if there is a prolonged security breach, you will not be able to know. Today, if any company or any organization is able to identify the breaches because of proper security and monitoring practices. So this is where audit logging comes into picture as well, right? So with audit logs, you log every create, read, update, delete operation, and over a period of multiple days, you identify these patterns and make sure you look at these patterns and make sure these are what you're looking at, and these are expected. Basically, every organization has weekly meetings, and in the weekly meetings, you end up reviewing these dashboards so that first you are able to identify any service degradations and also these anomalous patterns. Coming to the conclusion, what I would start with is, first, make sure your APIs are patched. You remember the Log4j vulnerability that we had 2-3 years ago? The world went haywire fixing that. And the vulnerability that was exposed also was critical of that. So that is why make sure your API's vulnerabilities are patched. And this is actually not very hard to implement. For example, let's say you detect a vulnerability, you just fail your build saying no build will progress unless this particular version is patched, right? Next, enforce proper authentication and authorization. When it comes to authentication, validating the JWT tokens, validating the expiry dates, hashing out your passwords, and suggesting stronger pattern or password for the user. That is what authentication comes in. And coming to authorization, this is where you would check for if this user is valid to do this operation or not. And then finally, continuous monitoring. Always keep monitoring your resources and make sure there are proper alarms set up, because these are what will save you. When there's an incident happening, what all matters is how soon you have identified it and how soon you're able to deploy it or mitigate it. If the time to mitigation is more than an hour or two, that means your servers are being extensively exploited and your user data is already put at risk. So that is why all these things in action will make your API robust and make your users feel safe about using your product. That's it, folks. I hope you enjoyed the talk, and thank you for having me here.
Wow, Siri, you covered so much in like about 35 minutes. And you know what's really funny? When you showed the code for the very first time, the very first API request, I really stared, like I couldn't find the difference.
Uh-huh.
So I was like, okay, I'm definitely missing something. And then you said those two code look the same,
Yep.
but it's more like a homework now. Everybody's watching, right? All
Mhm.
that Siri has shared, right? Take it as your homework and try to make changes that he
Yep.
suggested. I think that's would be very nice. We have actually a few questions before we wrap it up.
Yep.
There's a question by Sophia. She's asking, what's the best way to handle sensitive data in API responses to prevent excessive data exposure? We often end up sending a lot more data in the response than it's needed.
Yeah, that is actually a very good question, right? So, preventing excessive data exposure. So this is where I would say this is where the object level property authorization would come into picture.
Mhm.
The first question we need to ask is, does this attribute need to be exposed at all? If not, when the response comes in, when a request comes in the response object, don't include that property at all, right?
Okay.
That is one thing to start with. Second, there are valid scenarios where you have to expose some APIs, right? For example, let's say I'm going to DMV, and on the DMV website I need to check my driver license information, my date of birth information. This is a valid scenario. In that case, what I need to check is if the driver license that I'm showing actually belongs to me and not somebody else. So having these proper authorization checks are what will protect you from exposing excessive data.
That's very well answered, Siri. Where do you think the use of GraphQL can help? Do you think using something like this, like in GraphQL, can help over here? Sometimes we use it, right? When we work in the projects, like, okay, why don't you use GraphQL? That kind of limits it. Even when you're making an API query, you just need few
Yeah,
details
so
there.
I think where GraphQL comes into picture is when you're hosting the database, right? So
Yes.
the GraphQL is similar to SQL, how like SQL is a construct, GraphQL is
Mhm.
also another construct that hosts data. But your API is what pulling the data from any of these data stores,
Hmm.
right? Now, when I'm pulling in the data, because I know which API it is, I can write the proper select statements that would only pull in the information required. So
Yeah.
that is one way to offer the protection to not expose excessive data.
Perfect. Thank you for answering that. We'll take one more question by Scott.
Yep.
He's asking, how do you balance strong security measures with a smooth developer experience for the teams consuming your APIs?
Yeah, I think this is always the tricky point, right? So you want to offer security, but the developers are like, no, we don't have time for this and stuff.
Yeah, just ship it.
Yeah, just ship it. Those are valid, but I think where I would start with is to answer squad questions, provide as much as comprehensive documentation and as much less manual work as possible, right? So for example, let's say I'm developing an API, right? We as organizations are already building ton of APIs. If my APIs follows the same practices that other APIs are following, that means there's an API review board that is telling, hey, this is what every API developed by this organization has to follow. For somebody adopting it becomes easier because everybody follows the same authentication scheme, authorization scheme, data access patterns, and so on. So setting up that standard, and the documentation for all this will live in one particular place, and it does not change for API to API. That is what makes it easy for anybody using your API. And this is where I would say the developer review boards also come into picture. For example, any of your public facing APIs, right? There should be always a board that would look at it and say, hey, is this following the patterns that my organization has established? If it is not, straight out rejected. So
that's very
yeah. That is what I would say.
Yeah, it's a very nice approach, I don't know how easy it is, to implement in a consultancy world, right? So, and I live here in India, so it becomes a little challenging to do things like this. I think it's more possible to do it in a product-based companies, right?
Yeah.
We have board members and they decide everything. In most of the cases, right, especially since I'm in India, I can relate to that. If a client needs this jobs to be done, so it's just done. People get on a whiteboard, they decide this is what the endpoints are gonna be like, and then but developers thinks, okay, he does it, does not work, and then also it ends up changing, right? So I think there should be a document, where at least even if for not for the entire company, then at least for a project that you're making, there should be some guidelines that can be implemented at least.
Yep. And also automation, right? For example, there are code analyzers that you can build that would make sure you're following the security best practices. Second, once your company or organizations or teams start building these APIs, right, there is a automation to build the SDKs out. So these automations require the properties to be in certain way. So you're saying by incorporating these automations that, hey, you all should follow these best practices, and then only this automation would work. And the only way to go public is through this automation. I see organizations doing that, and that has basically enforced the best security practices. And last but not the least, it is also the security culture that comes into picture, right? You as a senior, or you should, when you're reviewing the pull request, it is also important that you view it from the security standpoint. And once you start offering comments like that, you would also see the team doing that.
That's very good, I think, and I'll go back and rewatch your session once again, Siri. And I'll take some notes, and maybe not in my current project, the new project that comes in, I'll implement a few of these. I know, I can implement all of them, but I'll definitely take some notes, put it in the Notion, and maybe even tomorrow call, I will tell them, what, go and watch this episode. We do all the things, but we really ignore these basic things, standardization, the security. Most of our daily sprints is all about completing the task.
Completing
right?
the task.
So it was a very good session, Siri. Thank you so much for sharing your pearls of wisdom. Right, I know everybody who's watching now and later on, they would really learn a lot from it. Any final thing you want to plug in before we wrap up the day one of this conference?
Sorry.
And any final thing you want to plug in before we wrap up your session?
I had a great time here. That is one thing I wanted to say. And you're a great host. The conference is pretty good. Let's keep doing this every year. But at the end of the day, what I would say is go build secure APIs and always keep security in mind.
Yay, hooray. And Siri, we would love to host you whenever you're in India. I don't know when was the last time you're here, but whenever you're here, we do a lot of in-person conferences.
Yep.
Right. I've done around 10 of them in last 6 months all over India. So I'd love to host you whenever you're here. Thank you so much, Siri. Have a great day ahead, and let's stay in touch. And yeah, thank you once again.
Thank you, Simon.
Bye-bye.
See you.
Well, ladies and gentlemen, that was Siri for you with an absolutely stunning session about APIs, right? If you have missed any part of this session, you can always come back to this conference website or YouTube, where you're watching this. So you can always come back and rewatch it, right? That is it, actually. And we wrap the day one of the Software Architecture Conference. Tomorrow, we come to your screens at 8 a.m. Eastern Time, and a little early for the folks living on the other side of the US. But yeah, there's the whole world here. So we can also give sessions to them. All right, ladies and gentlemen, thank you so much. That was it, day one. We'll see you tomorrow at around 8 a.m. And until then, take good care of yourself and